लाइक कर रहा है
मैं भी थोड़ा सा लेट
पता नहीं है कि कैसे बना है, क्या बना है। हाँ
कार वगैरह हिल जाए वो लोग एक्सेस करें ना ये लोग।
मैंने बहुत सामान रखवाया
वाला है क्या मतलब? हाँ उसको खुलवा लो, वाला एक्सेस करो। इसमें क्या कोई भी अगर आपको गलती से पैर लग गया वायर में तो सिस्टम बंद हो जाएगा, फिर आपका इवेंट ऐसे बंद हो जाएगा। नहीं वो खुलवा लो, खुलवा लो। ये फुल वाला सब कनेक्शन है वायर से, कहीं भी लगे यदि गलती से पैर से सब वायर जा रहा है, पूरा सिस्टम बंद हो जाएगा। एक बार बता दो। म्यूट मोड में आपको अनम्यूट करना है तो यहाँ क्लिक करो, म्यूट मतलब पुश करो ऐसे म्यूट रखो वैसा। हेलो हेलो कलर में कहाँ
फ्लावर्स
इसे एक्सेस कम करो,
प्लांट
सिस्टम थोड़ा इतना ये तो म्यूट मोड में है, एरो लाइट है। जो भी आप म्यूट रखोगे स्पीकर देना हो तब आप म्यूट कर। इसका पेन का कहाँ है ये है ना, थोड़ा लगा लो यहाँ, फिर आप ये हटा दो। ऐसा नहीं बोलो, वैसे दूसरे नहीं ज्यादा ये म्यूट मोड है, ये रखना म्यूट मोड में, ठीक है हम बाद में शो करेगा। जब स्पीकर लगा दो फिर अनम्यूट कर, सारे अनम्यूट ही रहेंगे। अब सारे अनम्यूट ही रहेंगे, वैसे फिर वॉइस कैच करेगा ना। तो मॉनिटर कौन है, वॉलंटियर है एक में दो लोग सुनो, एक किसी के यहाँ पर रख दो जो आपको यहाँ से पीपीटी वगैरह कलर माइक हैंडल करेंगे, ठीक है। हाँ अभी तो एक पीपीटी है, अभी के लिए पीपीटी ऑन कर दिया, स्पीकर कलर माइक लगा दिया, इसको अनम्यूट कर दिया, तो बोर्ड में है तो मुझे माइक हैंडल करने में तो एक लोग चाहिए क्या, दो
वो डब्बा में लगा दो, एक ही छोड़ दो।
उसको क्या है ना, वायर एक बार ईपीएस कनेक्शन है, सब कई पैर लग गए। हेलो हाँ प्रीतम बोलो। केवल मैनेजर आता है लगाने वाला, तो खरीद दे देना, केवल मैनेजर का हैंड नेटवर्क लगता है ना। इसका ग्रीन लाइट मतलब क्या है, ऑन है क्या? नहीं इसमें ऑन म्यूट है, इधर रेड दिखा रहा है। इसमें थोड़ा अलग बैटरी फुल है ना, इसमें बैटरी चेक कर कब किया था, सुबह किया है।
मेरे जाऊंगा माइक
नहीं चेक कर लो, इसमें तो एक कम दिखा रहा है, 2 दिखा रहा है, इसमें 2 दिखा रहा है, चेक कर सकते हैं। लो इसमें फुल है, ठीक है कैसे चेक करना, कितने हैं पूरा है ना, नीचे वाला 1 2 3 लाइन दिखा रहा है, 3 मतलब फुल है, ठीक अरे जो कलर माइक कर दो, ऐसा देखो नितिन भैया
All well. How are you? I'm fine. मैं कल को डायरेक्ट फ्लाइट है तो कल शाम को 7:30 हाँ I'll be leaving tomorrow today and then direct flight.
वो लाइव में
Yeah.
ऑडियो नहीं आ रहा है क्या? Cool.
कलर माइक यहीं पे ठीक है। हाँ नहीं चल रहा क्या आपको?
नहीं यहाँ पे लगाऊंगा तो ये जो आवाज़ है वो भी कैप्चर कर रहा है, मतलब सबका डिस्टर्बेंस आ रहा है, वही भी सामने ही लगाऊंगा।
तो डिस्टर्बेंस आ रहा नहीं आ रहा ना?
नहीं यहाँ से भी ऑडियो कैप्चर कर रहा है। हाँ
पीछे लगा लो, ले जाए साइड में पावर पॉइंट है
तब तक वहाँ तक आना चाहिए ना, वहाँ तक आना चाहिए साउंड अच्छे से।
वहाँ साउंड तो इसके कैप्चर कर रहा है ना, ऑडियो क्लियर से कैप्चर पीछे ना पावर पॉइंट देखो लगा लो।
हाँ
तो वहाँ पे कम आएगा कि यहाँ तो कोई ना कोई आते जाते रहेगा, कोई बोलेगा डायस से बोलेगा।
यूट्यूब लाइव ही है ना, मतलब उतना मतलब छोटा डिस्टर्बेंस आ रहा है बोल के बोल रहे
कर लो कोई
हाँ वहाँ पे डिस्टर्बेंस हो रहा है, मतलब सब बात
आप कभी सर इतने सारे फ्लावर्स देखे थे, साले हो गए। So I was telling them कि हमारे कुछ मतलब flowers are not very happy. Even if you plant them, ऐसा सुने? हाँ but in our campus you'll see lot of green, but not yellow and red. पहले तो नहीं अब थोड़ा सा आए ना flowers
because it is capturing the audio.
Sir, Professor, use
Hi, pleasure meeting you, yeah. Hi Gaurav, कैसे हो?
I'm so sorry, sir. I thought I should not bother you with this. I sent it to you. Sir, I called in the morning. Like, sorry, sir. My last Tuesday, there are 126 people. Close this door, please.
A very good morning to one and all.
I'm Arya,
I am Adil.
and it is our pleasure to present to you the fourth annual meet of the Department of Earth and Environmental Sciences at ISEC Bhopal.
The initiative aims at celebrating the several minds that have taken up upon themselves to cultivate the knowledge nurtured by the earth. The event will last for 2 days, that is 15 Hanses theme, and we have many exciting and interesting activities such as quizzes, seminars, debates, and many more.
We are gratified to have received immense support from our Honorable Director, Professor Gobardhan Das, on this occasion. Thank you, sir, for being here with us today.
The Earth and Environmental Sciences Department at ISEC Bhopal, in its very essence, is made unique by the comprehensive nature of it. It endeavors to be truly interdisciplinary, integrating principles of natural sciences and engineering sciences.
The department currently offers a doctoral degree, PhD, and an integrated Bachelor's of Science, Master's of Science, that is the BSMS dual degree in EES, Geology, and Environmental Sciences. In addition to a major in EES, the department also offers a minor to the BSMS students. This offers students a unique opportunity to build on their foundation as per their research interests. After all, we are not just scientists, but historians, storytellers, and wizards who predict if it is going to rain on you today.
Now we would like to invite the chief guest, our honorable director, Professor Gobardhan Das, the head of the department, Dr. Jyotika Malik, Professor S.K. Tandon, and Professor Srinivas Vilankar to light the lamp.
Sir, senior person is always. Please, sir, come. Sir, I अपने जो आपको Professor Vista, please join us.
I would now request the dignitaries to take their respective seats on the dais. I now request everyone to please stand up for the Saraswati Vanda.
Now, I call upon stage Namita Pinash to present a token of felicitation to the dignitaries. Moving ahead, we would like to invite the head of the department, Dr. Jyotima Malik, to deliver the welcome speech.
Good morning. Professor Govardhan Das, Director ISR Bhopal, Chief Guest of today's ceremony, Professor Tandon, Professor Bilakar, respected deans, other heads, faculty colleagues, students, our distinguished guests, ladies and gentlemen. We are gathered here today with a shared sense of excitement and purpose to celebrate the annual meet of the Earth and Environmental Science Department at ISR Bhopal. This event signifies not only a gathering of minds, but also a celebration of collective achievements and aspirations of our esteemed department. Throughout the next 2 days, we have meticulously curated a diverse array of scientific, extracurricular, sports, and cultural activities, all aimed at fostering collaboration, sparkling creativity, celebrating the remarkable successes of our department. I extend my heartfelt gratitude to ISR Bhopal for graciously allowing us the opportunity to organize this event. Furthermore, I wish to express our sincere appreciation to our esteemed sponsors, including Thermo Fisher, Swan Environmental, Yantriki Solutions, SK Traders, who generously contributed and has played a pivotal role in making this event possible. This year's theme, Let's Go Green, resonates deeply with commitment to sustainability and environmental stewardship. It aligns perfectly with our Honorable Director's vision to make ISR Bhopal carbon footprint free in the near future. As earth and environmental scientists, we organize and recognize our pivotal role in addressing pressing global challenges from reducing carbon emissions, exploring sustainable energy resources, to mitigating environmental pollutions and forecasting natural hazards. Currently, the department comprises of 15 faculty members along with 2 adjunct and visiting professors. We have 62 PhD students, 2 postdoctoral fellows, 98 integrated BSMS students, 33 project staffs, 6 office staffs, bringing our total department's membership to 218 individuals. I am immensely proud to share some notable achievements of our department over the past year. The dedication and hard work of our faculty and students have resulted in numerous accolades, recognitions, including prestigious awards, travel grants, research opportunities. Their accomplishments exemplify the spirit of excellence and innovation that defines our department. Over the past year, from March 2023 to present, we have received 7 external projects, securing a total funding of around 3 crores. Additionally, our department has published 45 research papers in last 1 year. Our department's achievements are exemplified by the successes of our faculty and students. I'll take a few names. Notably, Mr. Sunit Mohanty, a PhD student in the department, received India Scholar Network Student Internship, Commonwealth Scientific and Industrial Research Organization CSIRO Program Award. Furthermore, 2 of our students, Amit Kumar Moria and Anubhuti Singh, were awarded prestigious travel grants from EGU 2024. Several members of our department have been recognized for their contributions, including Mr. Abhilash Singh, Mr. Gaurav Solkar, Mr. Amit Kumar, Ms. Diksha Haswani, Mr. Sarath Patel, who received various travel grants and awards for their research endeavors. Jitin Kumar has been invited for a 3 month research visit at the German Aerospace Center, highlighting the international recognition of our department's research excellence. Faculty colleagues have organized high-end workshops on geoinformatics applications in environmental research and geophysics for natural hazards, furthering our common commitment to knowledge exchange and collaboration. These achievements underscore our department's commitment to excellence, innovation, collaboration in advancing in the field of earth and environmental sciences. As we embark on this journey of celebration and collaboration, let us seize this opportunity to exchange ideas, forge new partnerships, and inspire one another to greater heights of achievement. In closing, I am thrilled to announce our upcoming activities, including the Rock Deformation and Structure Conference in 2024 October, organized under the aegis of Structural Geology Tectonics Research Group of India. I urge you all to immerse yourselves fully in the enriching experience that await over the next 2 days. Together, let us ignite the flames of curiosity, innovation, and friendship as we chart our course towards a brighter and more sustainable future. Thank you. Jai Hind.
Thank you so much, sir. Now I humbly request our Honorable Director to enlighten us with the
Good morning to you all. On the dais, Professor Bilatkar, Professor Tandon, our head of the department of EES, Professor Nitin Mamoli, and in the audience I see Professor Mishra, the honorable deans, faculties, guests, and my beloved students. I welcome you all for today's the annual day of EES, the department. Now the nation actually is going through this reformation. The buzz is called Go Green. Few days back, you heard that our honorable Prime Minister says now 1 crore families will install something called solar power, solar panels. Why do we need it? As you know, this fossil fuel is the one is almost like a chain on your feet, chain on your leg. This country is pulling behind. We have to be released from such poverty. In this direction, the nation is trying our best, the government is trying the best how to reduce the use of fossil fuel. And so as in this direction, a few days back we saw the news. In fact, in Bhopal, I'm talking about the Bhopal local, with a drone, it has been surveyed the number of the area of rooftop available for solar power. In fact, it is clear that the number of the solar panel we can put in there is sufficient for the whole city itself. Then why we are using the fossil fuel? That this is a kind of a poison. The emissions gas, the now, as you know, this is the carbon dioxide production is really that it is big concern is throughout the globe, global warming. Such kind of things, so therefore, I think the nation's voice today is so big. And we have to tap alternate sources of energy and how to maximum use of various technologies. In fact, our department, the Art and Environmental Science, is the leading department is showing path in various aspects of this direction. As you all know, this is very often I see our papers coming from the EES department are making the headlines in various news media. Why is that? That because we all are working for the development of the country, not only development of the country, but also protecting our environment. I congratulate all our ES faculties for the Bhopal is also now the into the promise that we also in near future would like to make the India's first campus as a zero carbon footprint. We are working in this direction. And our ES department is immensely helping and tirelessly working on in this direction. And once again, I thank you all. And also, as I am here as the head of the institution, you all dignitaries, so I take opportunities to introduce my institution. My institution is just very young, only 15 years old, but we made our place not only in the country but in the globe. We are now well known. The institution is throughout the globe. ISRB pass is going on. If you go anywhere, ISRB is indeed a recognized institution throughout the globe. We have 150 faculties and the hardworking, young, enthusiastic faculties. They're all coming from various expertise and they're doing science. We have around 2,500 students and all are working so hard, and I'm sure this institution can show the path in the country in very near future. Very soon we will be the leading institution, not only in education, but also showing path in various aspects in the country. Therefore, I'm proud of this institution and we look forward to work together with hand to hand. We will make this institution in the front row. Indeed, we are in front row, but we can always, there is room for improvement. We are going to do that and we are always working hard. And thank you and thank you for joining this morning. I hope you will enjoy throughout the day all the various lectures. And indeed, we learn something today and we let's go with. Thank you for your attention.
Thank you, sir. I request everyone to please stand up for the national anthem.
पंजाब सिंध गुजरात मराठा द्राविड उत्कल वंदा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
We will will all now discuss for a short tea break and we'll gather back again at 10:30 for the first plenary talk. But before that, we'll have a group photo session in the lawn.
Everyone, please join us for a photograph in the lawn.
सोलो कर रही हूँ सोलो का मैच होता है
ये लोग हैं
नहीं डाला है
वही कैमरा बैग देखिए ना कैमरा बैग ये नहीं ये दूसरा है
हाँ अगर वो लोग हाँ उनका कहना है अगर वो आएंगे तो
पेन दे दो मेरे को एक यार गुज्जू
क्या दो
पेन फोटो है ग्रुप फोटो
फोटो है
ये क्या पेन
आर्या आर्या
नहीं कुछ नहीं बिल्कुल
क्या 10:30 से स्टार्ट होगा?
हाँ
कब स्टार्ट?
10:30 से
10:30
किसी ने कुछ मांगा ही नहीं मेरे से। इधर कर ले सामान रहना दे अभी
प्रीतम गरीबा मैम को पूछ रही है क्या?
कल आएगा।
कल आएगा?
आपका है ना आज पे?
हाँ लेकिन मेरा तो कल था ना।
चेंज हो गया, इसी के वजह से चेंज कर।
ओके
Yeah, so it was. So I think you submitted the slides, right? Yeah, so the job is like that. It's scheduled at 11. It's final. So, okay, so you be here by 11. हाँ उसका बोले बात करेंगे एक बार चलेगा पास हाँ सीएस को सके
और नीचे
बीटीसी
बीजीसी अच्छा है फिर तो।
तो आप क्लास ले रहे हैं? कल जितनी क्लास लेते हैं उसकी हम लोग आगे में
आप लोगों की बैंडविड्थ कम है।
बैंडविड्थ नहीं, बहुत ही कम। और उसके बाद हम कहीं बहुत बिजी है।
तो आप आधी कैसे ठीक लेते हैं? शेड्यूल्ड क्लास तो लेते ही होंगे। सर क्या पढ़ा रहे हैं इस बार?
मेरा जो हार्डकोर
सेडिमेंटोलॉजी। तो इसमें तो मिक्स क्राउड रहती होगी, बीएसएमएस प्लस
इसमें है तो हमारे थर्ड ईयर बीएस के हमारे बैचेस बड़े हैं ना, 30 आई है
क्लास में, तब तो काफी बच्चे हैं।
टोटल 48 है। ईएस मेजर जो जियोलॉजी वाले हैं उनके लिए कंपल्सरी है, जो ईएस कर रहे हैं मेजर वो
ओके ओके।
अहमदाबाद में गर्म हो गया होगा।
सर क्या हुआ ना, बीच में एकदम से मतलब 3-4 दिन काफी गर्मी रही।
हाँ,
और उसके बाद
गर्म हो गया।
हाँ, उसके बाद अचानक से फिर एक और ये वेस्टर्न डिस्टर्बेंस का स्पेल आया, फिर ठंडा। तो वहाँ पे अभी बहुत ये चल रहा है जुकाम बुखार वाला। सो मच ऑफ फ्लक्चुएशन। जैसे थोड़ी गर्मी होती है, लोग कपड़े वपड़े उतार के घूमना शुरू कर देते हैं, मौसम चेंज हो। बट यस, जैसे यहाँ पे पानी आज बहुत ठंडा लगा मुझे। मैं तो ठंडे पानी से ही नहाता हूँ।
अच्छा,
आई डोंट यूज गीजर।
तो बहुत ही दिक्कत हो जाएगी।
तो उससे मुझे लगता है कि यहाँ का टेम्परेचर
बहुत
प्रॉब्ली
बॉम्बे से मैं यात्रा कर रहा था, एयरपोर्ट जा रहा था, वहाँ से
4-5 डिग्री कम हो गया।
कड़ी धूप लग रही थी।
हाँ, नहीं दिन में वहाँ भी बहुत हो जाती है, सुबह शाम की सर्दी।
सवेरे तो कोहरा
हाँ आज कोहरा।
आज तो यहाँ
हाँ,
हम तो सवेरे टाइम रहते हैं 50 मीटर की दूरी।
हाँ,
AB2 से AB2 का लास्ट में दिखा गार्ड खड़ा हुआ था लाठी पे से करवा
सामने वाला ब्लॉक
वही नहीं था वो ऐसे गार्ड वो नहीं बस स्टॉप वहां पे कहीं ऐसे लाठी वाठी लगा रहा हो दोनों को लगा कि आगे गार्ड है दिख नहीं रहा है सामने ये इनको तब क्या पड़ी सेकंड नंबर पे मैडम
अरे नहीं काफी अकम्प्लिश्ड है
या
कॉलेज
इकोलॉजी सस्टेनेबिलिटी लाइफ साइंटिस्ट है 97 की पीएचडी है
सब कुछ सब पता है
सब तो ऊपर बैठे हुए
इंजीनियर और स्ट्रॉन्ग
का प्रमोशन भी किया उसका बस ये कह रहा सब कुछ पता है हमको हो सकता है का प्रमोशन भी शुरू कर सकता है
आई नो है वेरी वेल
यहाँ पर वो नोबेल लॉरिएट इंजीनियर ऑस्ट्रोम के साथ काम किया तो ये जो वो शी वाज एन इकोनॉमिस्ट प्लैनेट अंडर प्रेशर वाला जो ग्रुप था ना
हाँ
तो वो प्लैनेट अंडर प्रेशर की रिपोर्ट है 2012 उसमें तब से ये बड़े लोगों को बहुत बड़े लोगों को वो इसके 25,000 साइटेशन है
ओके शी इज मोर ऑन इकोनॉमी
social dimension plus the
Social science.
she's a trained life scientist, forest biodiversity or
forest biodiversity. That would be good actually. I have to
and also urban
yeah see there's a lot of
इसकी किताबें बहुत हैं
urban commons
and there is another side to her. She writes crime fiction.
wow
इसका जो किताब है 2022 की top 100 books of the world.
आना चाहिए इनको उनसे भी कुछ मुलाकात
she's not coming
She's not उनके पास she is very sought after.
अच्छा
so she invited me I will be visiting her on
हाँ मतलब
उनका कुछ तो इंटरव्यू भी करती है
हाँ वो पॉडकास्ट
तो उसमें पॉडकास्ट हुई है और एक टॉक हुई है मेरा वहाँ पे अजीम प्रेमी I know her before we both were in the mega science vision जो प्रिंसिपल साइंटिफिक एडवाइजर
अच्छा विजय
हाँ 2030 विजन में हम दोनों आखिर थे so then I first time knew about her
AR5 में
हाँ she was lead author
आपका टॉक
हाँ
you have his talk ना
वाले लोगों को
मतलब बुलाना पड़ेगा
तो क्या करती है
लंच तक
अरे we need to remove this ना यार या मतलब अभी तक किया नहीं to start sir has to speak
क्या ये टेबल हटाएंगे
हटाना तो चाहिए सर अदरवाइज आप स्पीच के लिए थोड़ा
don't want to remove I will manage but
सर एटलीस्ट वी कैन शिफ्ट इट
पीछे को कर दो
हाँ वही करें इसको थोड़ा हटाएंगे
It seems I'm abandoning women. You can relocate. No, we have the best gender diversity on campus.
I can see that in your department also.
अरे इंडिया में
कितना 50-50?
nearly.
That I think Gandhinagar, I guess it's 20. Not in department, not in campus. 20 to 20.
Ashwini,
Department.
Ashwini, can you call everyone? Just
Token.
वो तो अभी कुछ
Absolute token.
after donor it will be I think 25%. Since we have a very small number, we can get benefited.
What's up? I'm doing the work.
okay. We should start, sir. है ना एंकर अंदर? हाँ, we will. Start करो यार, you start guys. अरे आ जाओ आ जाओ. Come.
Welcome back, everyone.
The next session will be conducted by Professor Vinod Mishra on atmospheric and land drivers of prevailing floods in India. Professor Vinod Mishra is currently a Vikram Sarabhai Chair, Professor in Civil Engineering and Earth Sciences at IIT Gandhinagar. Prior to joining IIT Gandhinagar, he completed his PhD from Purdue University and postdoctoral fellowship from the University of Washington, Seattle. Professor Mishra examines the role of climate and human interventions on water resources and hydrological schemes. His research work has been published in the leading journals including EES, Nature Geoscience, Nature Climate Change, Geophysical Research Letters, and Water Resources Research. He received the Devendra Lal Memorial Medal from the American Geophysical Union in 2021. He is a fellow of the American Geophysical Union and the National Academy of Sciences, India. He received the Shanti Swarup Bhatnagar Prize in 2022. He is currently serving as an editor of Earth's Future and associate editor of the Journal of Hydrology.
I request Professor Ranga Sundaram to felicitate Professor Mishra with a token of bouquet.
I'm also clearly a conjurer. I can conjure. Flowers and campus flowers.
Yeah, I hope there is no glucose so we can put this out. Okay. Louder?
Sir, if you stand here, I think then
No, I think
the echo will not be
it's a
there.
way more louder.
नहीं सर अभी ठीक है
Okay, good morning everybody. So first of all, thank you very much for inviting me on this your EES annual day, and it's a real pleasure to be first time at ISR Bhopal campus. You have a wonderful campus with a lot of flowers. You know, this our campus. So thank you, Professor Ramya, for your kind invitation, and thank you everybody else. Professor Tandon is here. He has been mentor, and for a long time I know him. So it's really good to see all of you. So this talk I am going to present today, I will give you sort of an overview, and the idea is not to tell that what we have done in terms of research in our lab, but the idea is to sort of tell you that how big this problem is and how much more we need to do. And so that students feel that this is the topic or potential topic which needs a lot of attention, especially from the community or departments like yours and ours. So I'll be talking about atmospheric and land drivers of riverine floods in India. And floods are of many types, so I'll give you a brief overview that what are floods, how do we define floods. I will also tell you that, you know, how different skills or what are the skill related challenges, how floods evolve, what are the major hypotheses about floods, and then we will move towards what we know about floods in India, especially riverine floods, talking about what are the conditions that atmospheric conditions that basically lead to major floods, and why floods should not be thought about driven by just atmosphere. Many times people feel if there is a heavy rainfall event, there will be a flood. And this is sort of not a proper understanding. So that the role of land is also crucial. And then we will discuss about, basically the work that one of my PhD students did, who is currently a postdoc at Princeton. So her thesis work I will present mostly, and then some work by other students on atmospheric rivers. So eventually I'll discuss like what we need to do to take care of or tackle the challenges of flooding in India. Because many times what happens, we are very good in identifying the problems, highlighting the problems, telling people that how big this problem is, but not thinking about how we can solve the problem or what we should do so that we can, advance the understanding, not only understanding, but also providing solutions. So this science to solution, transition is extremely important in today's world because we need to solve problems. Okay. So I'll start from the monsoon. If you look any monsoon season, summer monsoon season, and you see our country, lot of places you will see the pictures like
So monsoon is really important. It is lifeline. It supplies water, about 80 to 90% rainfall. Total annual rainfall occurs during the monsoon season in India. So monsoon is also one of the major drivers in our country of hydrological extremes. And when we talk about hydrological extremes, that includes droughts and floods. You know. But the challenges with monsoon is like monsoon is never uniform. So any year you take, you will see pictures like this, which is showing the spatial variation or distribution of rainfall across the country. So red areas show very high rainfall and blue areas low rainfall. And this pattern changes multiple times within the monsoon season of 4 months, June to September. So you'll see phases where some parts are very dry, some parts are very wet. And if you take the seasonal total rainfall, you'll see some areas have received a lot more rainfall than the normal, and then some areas lack or were rainfall deficit. Now, what are the problems associated with kind of temporal and spatial distribution? That this temporal and spatial distribution will cause extremes both in space and time. So, as seasonal time scale, you will see areas will face droughts where rain was very, very less, and the areas will face floods where the rain was very, very high. And it could happen not just once, multiple times during the time frame of 120 days or 4 months, which we call summer monsoon season. Now, if you look at the history of floods in India, so this is the data I collected from some source. What were the major flood events? So, the biggest is the 2013 event that caused estimated mortality is more than 6,000 people, and that is the reported mortality. We also know this event as a Uttarakhand flood event, and many people sort of got missing, many died. But there were a number of major floods that caused more than sort of 100 people died, in the recent 2023 North India floods that caused flash floods in Himachal Pradesh, floods in Delhi, and other parts, especially in North India. But if you look at the major events, they are well distributed 1943, 68, 78, up to very recent. And mortality estimates, if you see, after 2013, we did not see that kind of a mortality. Level of flood 2018 got something around 500 people. These are really large numbers, but when we do the relative comparison, we may see 100 people is very less number, 400 is less compared to Uttarakhand. So over the years, this mortality has declined because of various advancements that we have made, but the damage because of floods have gone up. Why that is the case? Because now we are probably better informed in terms of early warning systems, but damage, economic damage will keep rising because we are putting more and more infrastructure that is exposed to floods. So while we can control the mortality, we cannot control somehow the economic damage to infrastructure, agriculture, etc. So what essentially we can take out of this that in India floods do occur at a larger scale and they have a massive economic impact and they cause very significant mortality, only human but also animal mortality, which we don't estimate in terms of numbers most of the time. Now, so I will be focusing on riverine floods to give you a very quick overview what are riverine floods. Riverine floods are flooding in rivers, which will when rivers actually will be overflowing or they have water more than their capacity. So water will overtop the banks and it will inundate the surrounding regions, so that we call riverine floods. Then we also have pluvial floods. Most often you might have heard about urban flooding, the most recent one in Chennai, right, in the last year, December. And so that basically these are mostly driven by just heavy rain events. And because of very short duration intense rainfall events, your drainage system will choke and then you will have flooding across the city. And that will disrupt traffic, that will, also damage your houses, roads, and industries, whatever. But very large economic impact as well. Last one is coastal floods. So these are the major three types of floods. If you want to know that what are different types of floods, coastal floods occur because of cyclone, storm surge, tsunami, and they come with very high winds, extreme precipitation with storm surge, and then water can move towards, towards land from sea, and that can also cause flood. So today's focus is riverine floods, the first one. So here we will discuss about floods in larger river basins in our country and how they are changing, what is the role of land and atmospheric drivers that cause those floods. So if you really want to understand floods, I can tell you that Gunter Gosel is the author you should read. And he is the person probably very nicely did wonderful work and towards our understanding about floods. And I am taking this, all this data from this paper. And that tells us that how flood process or flood generation process, it starts from a very smaller spatial scale, millimeter scale, and can move to continental scale. And so pores, profile, hill slope, catchment region, and continent. And that is something like that will give you that why this process itself is a complex. But the key thing is that preferential flow and hydrological connectivity are the two fundamental requirements that will basically make or connect these smaller scale to very large scale. So you need hydrological connectivity and you also need preferential flow. And whenever that happens, you will see that flood generation process starts and larger floods can occur. So these pictures give you a sense what happens at a very small scale. This is a profile scale showing that, if you put the pressure, there will be heterogeneous distribution in the soil column that also tells about the preferential flow. And this is the hill slope, that how the channel collectivity or runoff from hill slope peaks once you see different stretches starts connecting together. This is about catchment scale, that summer event, what is the soil moisture condition here. Blue means high soil moisture. Blue means high soil moisture, red means low soil moisture. This is the winter event where soil moisture is very high. So, in any given region, this is basically regional scale. Any given region, you may identify the causes that what drives floods. So, for instance, here, this is, I think, Austria. They did the study, so it highlights snowmelt floods, flash floods, where do they occur? And this is a fraction. So, it highlights like these red spots get most of it flash floods. Then rain on the snow floods. You see here, the snowmelt does not cause that much floods, but the combination of rain and snowmelt can cause lot of floods. And then synoptic large scale floods, that these are driven by synoptic storms. Also, one thing we need to understand that hydrological connectivity, and that tells us that in a river basin, how different sub basins, even smaller, can contribute and give a shape of very large stream flow events that you can see here from the hydrograph. This is the scale, and these are the contributions from different parts of the river basin. So the connectivity also very, very important. Okay. And this is the continental scale. Remember, this is the continental scale. Last one, that was the regional scale, right? This is the regional scale. So continental scale, when you will see that a major part of country or South Asia got flooded. And that will happen when you have a very large storms, and here this is defined by storm tracks in Europe. You see like how big major storms will dump a lot of water over land, and that may cause flooding in several countries in the almost similar time, right? So there are three major hypotheses about the floods in river basin. Again, from Gunther Bloschel from his recent paper published last year, and it tells us that land use change. First hypothesis is that land use change, such as deforestation, urbanization, increase flood hazards. But what has been found through this hypothesis that only small catchments will basically land use change is important. If you talk about the Ganga River basin, land use change like urbanization will not contribute to riverine floods. Okay, so this is you can link these three hypotheses to flooding anywhere across the globe, I guess. The second is hydraulic interventions such as river training, levees, dams, increase flood hazard, and that is so. Oftentimes we call them flood protection measures, but the hypothesis is that they oftentimes increase the flood hazard rather than reducing. Okay, so when it is tested, that it is found like these have great impact on medium magnitude of the events, return period 10 to 100 years, and their effects are usually local. So, for instance, you have a small dam break happened, and there will be a flood in a local catchment area, right? So, this is our second hypothesis. Third hypothesis is very important, and I will show some of the cases in our work also that climate change increased flood hazard. Uh, so basically, what they have found that yes, this is true. If catchment size is small, flood hazard increase due to convective storms, which is directly related to climate change. So the hypothesis is that, or the understanding is that, as atmosphere warms, we will get more extreme rainfall, and more extreme rainfall translates to floods. But that happens only to smaller catchments, okay, where floods are largely driven by convective storms or extreme precipitation. In large catchments where regional floods occur, changes are not necessarily directly related to precipitation. So we can say changes are not also directly related to climate change. Okay, so we talk about floods in Ganga River Basin or Godavari River Basin. These are not basically directly linked to climate change because extreme precipitation events may occur, but they may not lead to floods. Now, what has happened in India, so if you see the history of deforestation here, 1770 to 2005, and then this is the expansion of crop cover, and this is the recently developed data by someone, so we put this out. We see that historically there has been mega scale land cover change, okay? So we can say that this hypothesis that land use change does not has a role to play. So if you use this kind of transition, which has 200-year, 300-year history, you will see that floods are also caused by land use change. Okay, so you can counter that hypothesis, but at a smaller time scale, the idea is that floods are not directly, riverine floods are not directly related to land use change. India is heavily dammed. It is second most largest, I think, the country with large number of mega dams. You can see here major reservoirs and dams. Highly irrigated also, so these are the human interventions. So you can see the flow with dam and without dam. So we can change the, if you go downstream and see the flow, you will see this, that without dam flow, with dam flow, and also this case is from the Narmada Basin one gauge station. So dams affect floods or flow, and the third one is climate change, which is suggesting that we are going to sort of increase the rainfall as we move in the future. And increased rainfall may bring lot of floods in the country. Where that is the case, we are going to discuss. Okay, this is another review paper that connects every dot related to floods like exposure, impact, hazard, vulnerability, what we can do, how we can manage, how we can connect different aspects of floods. But if you look at this data set, this has a very sort of interesting message, and these are all observed events. And the circle of size, I think, gives you a sense that how big the event was. So, like this is the more than 1 million people displaced, and more than 1,000 people displaced. But what we see here, that tropics, this region, if you pay attention, as a lot of area where floods do occur very normally, with a lot of people displaced. And also one thing we can notice that this region, South Asia and East Asia, dominated by major monsoon systems, also very often get floods. Okay, so what we try to understand, like now I will start, giving an idea about the work we did in our lab, or Nandita did, one of my PhD students. So we sort of were interested to answer these three questions: that what are the key atmospheric and land drivers associated with riverine floods? To what extent riverine floods are projected to change in the future? And what are the critical challenges associated with flood early warning systems? And the idea is not only to understand the problem, but to sort of also design or develop solutions. So she started the work from a case study as a Narmada basin. So we took this basin to sort of understand like what happens, and then we extended the work for all the river basins to be found. So if you don't know Narmada basin, this is the best flowing river, right? And it is between two ranges, Vindhya and Satpura. These are the different gauge stations, A, B, C, D here, E. And so we looked at what are the processes, flood processes in Narmada basin. As usual, we use a lot of observational data. We use our model also, hydrological models. We first set up the model, tested how well model works. So this is the stream flow simulated, normalized stream flow. This is the observed versus simulated. These are the some numbers that will give you an idea like how well model was working. So with that, we first look at the monthly distribution of extreme rainfall stream at four these gauge stations, or the catchments upstream these gauge stations, and this is the percentage. This is starting from 15 day, every 15 days, June, July, August, September, October. So you can say we divided monsoon season 4 months into 8 periods of 15 days. And the extreme precipitation distribution, if you look at all these catchments upstream to these gauge stations, you will find out that extreme precipitation events mostly occur in July and August. Okay, most of them are single day events, because this is the distribution of duration and frequency. So most of them you see single day, rarely for few gauge stations downstream you will say 2 day extreme rainfall event occur. But if you look at the high flow or floods, most of the floods in the basin occur in August, not in July. And frequency and duration, if you see, the basin also experience a lot of events that are much longer duration than the extreme rainfall. Now, why is that case that floods occur in August and extreme rainfall mostly occurs in July? Anybody can tell? So that's where the disconnect or this time lag defines the role of lag. So first monsoon will come, it will create the favorable conditions for flooding to occur, and once ground is saturated, and then if extreme rainfall occur, floods occur in that kind of condition. So early monsoon season up to July, floods occurrence is not that common, but August you will see most of the floods in the basin occur. So we also looked at that if you take extreme precipitation events that caused high flow events here, you see about 60% events cause high flow or floods in the basin. So that means there is 40% chance that extreme precipitation will occur and floods will not occur. And that again defines the role of land surface, that okay, extreme precipitation on dry land will not cause flooding. If you take the reverse way, you take high flow events and see that before that what happened. How many high flow events were caused by extreme precipitation? You will see much larger numbers, about 80 to 85% flow events are caused by extreme precipitation events, and that combines the role of land surface as well. So we looked at some events, what happened in terms of moisture movement. So from where moisture came, how much how was the integrated water vapor, sea level pressure, all the how the atmosphere sort of uh, atmosphere played a role to bring lot of moisture over land. So that gives us an idea, and then also looked at that within a season, what fraction of flood events are caused by moisture from ocean and moisture from land. So you see, there are events in September and August that are not only caused by moisture from ocean but also from moisture from land. And that also tells us that lands become saturated. So there is a lot of recycling within the land to create extreme rainfall conditions that could cause floods. So after this initial work, sort of we started to look at the entire Indian river, all Indian river basins. So here you can see rainfall again. This is the monthly distribution that when rainfall events, maximum rainfall events occur. So these are the timing. July is the green, August is yellow, and September is somewhat brown. So July, and this is August. So this is the soil moisture. You see rainfall. Most event occur during July. Most heavy high rainfall soil moisture occurs July and August, and then after this initial setup, most floods occur during August. Okay, that tells that this is not only Narmada basin, but it happens across all the basins. Okay, all peninsular river basins. We did not use lot of stations in Ganga because observations are not available. So then we looked at that what are the drivers that basically can cause floods in all these river basins. So we looked at extreme precipitation, compound extremes of extreme precipitation and extreme soil moisture only, and multi-day precipitation, which is 7-day accumulated precipitation. So if you take 7-day accumulated precipitation, once that exceeds to certain threshold, the chances that it will cause riverine flood is the highest. So you see here the probability with multi-day precipitation is roughly about 0.83. So 80% probability is that 7-day accumulated precipitation is high. It will cause floods at the river basin. And that sounds like the most prominent driver. So if you take the like just 7-day precipitation, and why it is most prominent driver, because if continuously 7-day precipitation happens, it also creates favorable land conditions, flat surface conditions that can cause floods. So we also identified the dominant flood drivers at different sides of the river basins that you can see here. These are the drivers. Most of the cases, these are significant. Some places, these are not significant, but essentially what it gives us extreme precipitation, extreme soil moisture, but multi-day precipitation is that can create both land that can combine land and atmosphere at atmospheric favorable conditions that can bring floods to these large river basins. Okay, so what brings moisture to land that can create multi-day, 7-day extreme rainfall or 7-day rainfall total that are extremes? This could cause to floods in different river basins. So this Santi, one of other my PhD students, did some work on atmospheric rivers, and here we looked at how atmospheric rivers bring moisture that persists for very long duration and create favorable conditions for floods. So essentially what you are seeing here, this is from 1951 to 2021, frequency of atmospheric rivers, and this is June, July, August, September IBT, which is the moisture, atmospheric moisture, and this is the change in atmospheric river frequency. So if what we see here that both IBT and atmospheric river frequency has gone up if you look at the last 60, 70 years. We also look at what is the major contributing factor. So wind has changed that bring more lot of moisture over land for very long duration, and that basically can cause riverine floods. So this is another data that tells where all the major floods happened. I will not spend a lot of time, but this gives you entire data set, mortality area affected and people displaced because of floods in India. But what is important here that roughly about 70% of floods are associated with these atmospheric rivers. And atmospheric rivers are important because these are large scale, moisture carrying phenomenon and that dumps lot of moisture over land. And if you take at the top one third atmospheric rivers, roughly about more than 80% are associated with floods. So that means that atmospheric rivers bring lot of moisture from ocean to land, that persists for many days, and that creates a very nice setting for riverine floods in the country. So with that, we also looked at, we answered the question like what is the probability of widespread flood. So for instance, flood may occur in one sub-basin of a large river basin, let's say Ganga or Godavari. So what is the probability that multiple sub-basins experience floods at the same time? So in a gap of 2 to 3 days. And this is important to ask because in a river basin, it may not occur very often that most of these sub-basins will be flooded. And this will happen only when you have a very large storm persisted for many days and created favorable land and atmospheric conditions to cause flooding at multiple sub-basins. So those we define as widespread floods, right? And widespread floods are important because they are different from localized floods and the entire basin is affected. So you can think about the damage in terms of agriculture that will cause. So we looked at the widespread probability of different river basins using observations. So you can see here that which are the river basins that have probability to get widespread floods. And dark blue colors are the river basins where widespread floods occur more often. These are the basins where floods do not occur more often. So you can say Narmada, Mahanadi, and Godavari are the key basins where floods. And also, mostly 2 to 3 widespread floods occur per year in river basins. So these are not common. Many years they may not occur at all, and you can see here, right? For case of Ganga and some other basins, there are years, large gaps where widespread floods are still not occurring. So these are not that common. But we also looked at the probability and also seasonality. Again, August is the month where most of the widespread flood occurs, and these are the probabilities basically telling you that which river basin have high probability and which month widespread flood probability is high. For instance, you can see here, this is Mahanadi and Narmada. So Narmada again, August has the highest probability of 50% or so of widespread flood. Why do they occur? We also looked at why some basins have a very high probability, some basins are not. So one thing is important here: the distribution of rainfall and number of rainy days. So some basins like Ganga, you have a very large variability. So some basins have a very high rainfall, some basins have very low rainfall, and some distribution is for number of rainy days as well, as you see here. But these are the basins in the core monsoon setting. You see Narmada, Mahanadi, and Godavari. There, the rainy days and rainfall variation is not very high. So, entire basin will get, the similar situation that can cause flooding, and that's why widespread floods are. Now, how land affects that? So, this is soil moisture and base flow conditions when widespread floods occur and they don't occur. You can see very high soil moisture in all the cases, and this is very high base flow. Day zero is the day of flooding, and we estimated that for last 10 days from the day of flooding, and you can see how the base flow builds up, how the soil moisture increases. Shaded area is the variability among different subbasins, and then the line is the median of all the subbasins. So essentially, what we see from here that you may start soil moisture build up and also base flow build up, and in many subbasins at the same time, and that will cause widespread flood events. We also looked at some notable flood events in the, in all these river basins. These are the largest floods occurred in roughly last 120 years in different sub-basins. Again, we looked at the soil moisture and precipitation. Day zero is the day of flooding. You see, this is the atmosphere role. This is the role of land. This is the rainfall. So how these interactions can bring very large scale floods in different river basins. And this is what we can see from here. See, this is the storm track for Godavari flood in 2006. Dumped a lot of rainfall almost in entire basin. And then if you look at the day zero when flood happened, soil moisture was almost about 15% or 96 percentile, and then it builds up almost 100 percentile and during this time. And this event with high precipitation combined with high soil moisture released all the floods. Okay, do large floods occur in all these subbasins? We also looked at what is the common return period. So return period is mostly about 20 years or so. So not like 100-year return period or more return period will be faced by all these subbasins. So look at what are the normal range of return period and what is the fraction of subbasins that will experience widespread floods. So that distribution is also we have estimated and we have looked at the future, so how these major drivers are projected to change in the future. Remember, I mean, I told you like what is basically what are the main drivers. Now we can look at what models project in the future about those drivers. So for instance, multi-day extreme precipitation, whether that is projected to change or not. So green is the observed one, and red and blue are the two scenarios projections in the future. And both are saying like those are projected to change given that the models have their own uncertainties and things like that. Other thing is that, these are the basically increase in widespread flood probability in warming climate. So you can see here that probability in the historical period, these numbers represent, and these are the projections in the future for different river basins. Again, the probability in the historical period is very high in the central India or the core monsoon region, which is further is going to increase and primarily because there is a projection of increase in active cells during the month. So we are likely to have, if you believe on the models, we are going to see more active cells in the future as well. Now then we also sort of trying to develop flood forecasting systems. So this is again like we know this, what are the drivers. So if you know the atmospheric drivers, you can track them. If you know the land driver, you can track them. And then sort of you combine these things and put a flood early warning system. So I mean these are the prerequisites and you can read. We need high accurate weather forecast. Also the data assimilation, we need ground observations, modeling, etc., etc. So there are different elements related to flood forecasting systems. These are the challenges. Models are not perfect. The data is also, I mean, weather forecast is not perfect. There are a lot of uncertainty from different sources. But given all that, sort of, we tried to develop a flood early warning system for Narmada Basin. We tested it for 2 monsoon seasons, and it appeared like it worked out quite well. So we used multiple hydrological models. These are the skills. This is the flood inundation area at different lead time, 1 day, 2 day, up to 5 day lead time. These are the forecasted skill or flooded area compared to observation assembly from different hydrological models at different lead times. So skills are quite, they match quite well in terms of observations. And the current ongoing work is that we are sort of integrating all this multi-model framework with machine learning to address the question whether machine learning can further improve the sort of errors or uncertainties in hydrological models or weather forecast. So essentially, I mean, this is very busy plot, so please don't worry. I will tell you what is the summary of this. Summary is that if you combine hydrological modeling with machine learning, you can improve or enhance the predictability, and we tried different machine learning approaches, including like LSTM, random forest, and XGBoost, and combined with model with climate. So all combination possible we tested, and you see the model plus climate or weather data plus LSTM gives us the most or the highest improvement. That you can see here also, right? So this is the case for Narmada Basin. So whatever the models cannot take in terms of timing error or the magnitude error of flood peak, when you integrate models, especially the multiple hydrological models, with machine learning approaches, there is a great scope to further sort of improve that forecast. So I think this is the last slide of my thesis, of my talk. But I will summarize like what I covered because I don't have conclusion slide. So we looked at why floods are problems. We also looked at how floods, riverine floods especially should not be thought about just the response of extreme precipitation because land surface conditions, soil moisture, and waste flow also contribute greatly. We also looked at how flood probabilities are different in different river basins, what caused by these floods, how floods are likely to change in the future in response to climate change, and then finally how we can sort of develop flood early warning systems using the traditional approaches and with the further refinement of based on machine learning data simulation, etc., etc. So that's all. Thank you very much.
Thank you, sir. The floor is now open for questions.
So the mics are around. Please raise your hand if you want to ask a question.
Yeah.
Yes, I think I can ask.
There you go. What happened?
Sorry, sir. So you mentioned about this atmospheric rivers and its contribution to the flooding system. So like how much exactly is the contribution of atmospheric rivers to the floods in India?
So so that is a good question. So how we looked at? So sort of we got the floods database. There is a database that tells where and when floods happen. So we looked at that, and then we have the atmospheric river database created by us. So you'll see that whether that overlaps with the atmospheric reverse time. And then the third check was if it overlaps, whether atmospheric rivers produce, significant amount of rainfall during that period. Because you may see atmospheric rivers, but it may not rain also when it so all these three criteria when satisfied, then we said, okay, this flood was associated with atmospheric rivers. May not totally caused by atmospheric rivers, but there was a presence of atmospheric rivers that caused rain and that might have led to floods. So if you look at the statistics of last 45 years, roughly about 70% atmospheric rivers are associated with floods. Okay, and if you look at the top one-third atmospheric rivers based on their severity, so we identified roughly about 450 atmospheric rivers catalog. So if you look the topmost with the highest severity, that number goes up to about 80%. So that means that atmospheric rivers bring a lot of moisture for a long duration. And as I showed earlier, that the best predictor for riverine floods in India is if you take the 7-day rainfall total. That will tell you that whether floods are going to happen or not. And those conditions are created by these very large scale systems like atmospheric river. And that's why roughly 70% of them are associated with floods. Right?
how do you distinguish between monsoon and atmospheric river?
Yeah, that's a good question. And if you keep on asking that, reviewer also asked this. So basically there are ways to distinguish. So because monsoon flow also looks very similar to this moisture movement that happens due to atmospheric rivers. So we sort of used criteria that is sort of accepted by atmospheric river community. So atmospheric rivers should move up to or above some latitude, So at higher latitude in this moisture when it reaches, then only we call it atmospheric river. Unlike the moisture, the other differentiable factor was if you compare the climatology of the monsoon system versus atmospheric river, it is, atmospheric river has very high IDT conditions without any break in this entire moisture movement and covers very large band of moisture transport. So these are the three criteria that differentiate normal monsoon moisture movement versus atmospheric river.
So what is the reason of moisture movement? Because there is no other source except the monsoonal.
Of course. So these atmospheric rivers occur in the monsoon climate, monsoon system, and they occur in non-monsoon also. It's not only only in monsoon season, but predominantly they occur during the monsoon season. So we have identified atmospheric river during the non-monsoon season also, but those are hardly, I think, 10 to 15%. So about 85% occur during monsoon season. So the driver is monsoon, but the rivers are defined by some different criteria. So that's why we call them atmospheric rivers, not just monsoon. Yes. Yeah, sure. Anything.
So can
Yeah.
thanks, Professor Vimal, for bringing this new insight to address user plan. And I have few questions. So one regarding the probability, widespread probability distribution in the central India, for example, Nagara.
Yes.
So you said it's because in Ganga, for example, the wide distributed climate, I think rainfall.
So number of rainy days and total amount of rain.
So other than that, I was wondering because if you see the catchments say, so Narmada is more elongated. So of course the lateral variation in atmosphere, for example, precipitation and other say other things, the number of days.
Yeah.
Would be much less as compared to the illuminated plain because it has a quite catchment area and SAFE is also not illuminated. So do you think SAFE is controlling the widespread of highland?
So the way we defined widespread flood was, if you are in large subbasins, how many of them, more than 50 or 60%, I guess 50% of them get flooded in 2 to 3 days. Now, in a very large river basins like Ganga and Brahmaputra, because of this high variability of rainfall, getting a storm that can cover such a large basin and create a favorable condition for flooding is the probability is low. And the other region, if you Narmada, I know the shape is elongated, but if you look at Godavari has much higher probability than Ganga and even Brahmaputra. And the idea is these basins are located in the core monsoon region, where out of 140 days, 120 days, you will get many more rainy days. Not only that, the annual or seasonal rainfall distribution is very uniform. So it's not like one subbasin is very dry and one subbasin is very, very dry. So whenever, and also relatively these are medium-sized basins, so when the storms occur, so if you look at the track of atmospheric rivers, for instance, they overlap also these three basins, and that's why we call probably that 4 monsoon region. So, all this contributes that higher probability of flooding in these basins, not in Ganga or Brahmaputra.
This other thing I wanted to have your view on. For example, they say we claim in certain regions there is a depletion in groundwater, and that is going at very alarming rate. So, do you think that depletion of groundwater can also control flooding, extreme flooding, like riverine flooding?
Certainly. So it's we look at waste flow, and waste flow is very highly related with groundwater. So we sort of used observations, we separated waste flow for observed distribution flow. So if you see the waste flow during these large floods, also very high. So you will see a very high amount of waste flow. So the groundwater is very low depending on how that this river aquifer interaction happens in terms of geology and all other factors. Waste flow and groundwater both has very important role. Certainly.
That we can expect that where
People have already established that whenever terrestrial water storage is very low, even if rainfall is slightly higher than the normal, that will not cause floods. So these terrestrial water storage estimates come from satellites like this. Yeah.
Last, I want to learn this because if you see model and observation differ a lot. So most of the time we observe that peak is not
Matching. Yeah.
So what is the reason?
So this is the reason because of model state. So initial state of models is either dry or wet. So when you and the non-linearity involved, so then when the flow you route, it will give you some delay in peak or peak will occur even before sometimes if model state initial state is very wet. Now how we can improve initial state is through data simulation. And we have shown that when we use it through data simulation, we can correct the timing part. But good thing is if you don't want to do that, that machine learning can LSTM can correct the timing error, and that's why I say that machine learning or LSTM and approaches like that are extremely important because models oftentimes fail to pick the timing, and that is very important for forecast. Right? So if you are forecasting and you have 2 days timing error, your forecast will not work. Any other questions? Yeah.
Yeah, last one.
Thank you. Correct.
Thank you for an excellent talk. So, what I particularly like is you started from the observations and then identified the basic impacts and then used the modeling to further study the impacts and then you used a model also to forecasting. And plus now you mentioned that about the artificial intelligence of the machine learning. So when it comes into the forecasting error, you said that there are limitations. So how you identify your limitations? So this is like the like our current limitations of the current system, or it is based on the feedback processes that may come under these climate change scenarios.
So I can tell you, and don't worry about climate change when we do the forecast. Okay, so forecasting problem has two fundamental problems. So one is weather forecast. So extreme rainfall forecast, no matter what who is producing, it's very difficult to produce the magnitude of accurate forecast. So whenever very heavy rainfall will occur, your forecast will be only 50%, 60% of that magnitude. So that is one problem. The other problem is the spatial distribution. So the forecast will tell you that okay, heavy rainfall will occur in this place in the basin, and there may be 250 kilometers, 300 kilometers. So this is another problem. So there are challenges with weather forecast. Weather forecast is not perfect, and we don't expect to be perfect because of obvious reasons. The second challenge is with the modeling, hydrological modeling. As I was discussing with him, that models should have the ideal initial state. So models should know how the basin condition is today if tomorrow flood is going to happen. If models do not know that what is the basin condition, which we call initial state before forecast, so then you will see the bias, and that bias comes oftentimes from initial state.
How we fix that? We fix looking at the past 3 to 4 days observation, and we assimilate those observations to correct the initial stage. So these are the problems. Then other problems are parameterization, how good your calibration, etc., etc. Now these are the challenges, and then challenges. I mean, how we can improve on those. There are ways like one or two I have discussed, but any weather forecast, rare events, forecasting rare event is still a big challenge. If you give that forecast with some good skill, hydrological models can convert or translate that to a reasonable forecast of flow. But that is the problem. I can give you the example of Pakistan flood. Pakistan flood last year, none of the models globally picked that kind of magnitude. So most of the models only picked 40 to 50% of what actually happened on ground. And you know, when you have that, so models will give you that, okay, that is going to be extreme, not necessarily in terms of the same magnitude. In model space, it is extreme, but in observational space, you may see it's a normal event. So what we can learn from there is that we should not get the weather forecast extremes and compare directly to observational extremes in terms of magnitude. But in terms of signature, we should capture that and then estimate the probability that could occur of flood in a river basin or in a. But a lot of work is going on in this area. And I mean, from student community, I can say this is something where you can enjoy everything. You can use your data science, machine learning, computations, and combine it with the hydrology, combine it with the atmosphere weather forecast, and that integrates everything together and to give a solution. Or, yeah. I think that was the last question, no? Okay.
Yeah. Thank you for the very nice sharing those interesting findings. I had a question. I heard you said that not always the warming is affecting the flooding, right? So also soil moisture effects. There was, I think that was in slide 37.
Okay.
It would be nice if you could tell a little more about how that prediction
I'll
was
tell
done.
you. Yeah. So I'll tell you. So that is very interesting. You know, people figured out why extreme rainfall is increasing but not floods. This you can read. There are a lot of papers on this topic, and this is very interesting. Why? Because oftentimes people see heavy rain events are increasing, so floods will also increase in same proportion. But it doesn't happen because of the non-linearity or because of the role of land surface. Number one. Number two, when we talk about climate change, if you look at the data, so we have already published, I have not shared the results. If you look at the observed extreme rainfall changes in India, there has been significant increases, but there has not been any significant increase in riverine floods in the same basis. Why? Because the spatial distribution of those changes are not covering more than 10 to 15% of a river basin. Okay, so to get the meaningful increase in floods or proportional increase in floods, you have to cover the basin. So you may, so that we call riverine floods. But yes, climate change that cause a lot of pluvial floods that I have discussed. So those are directly or flash floods. Those are directly related with the extreme rainfall or convective extreme rainfall events, which are linked with warming because you have warming, atmosphere can hold more moisture, that can cause more extreme precipitation. So city flooding, urban flooding may have a much bigger impact, and then coastal flooding may have a bigger impact. Riverine floods are also likely to increase. I am not denying the fact that they are not projected. But if you look at the observations, they are not in proportion. So, lot more, they are a lot lesser than the increase in extreme rainfall.
Thank you.
Thank you, sir. I would request Dr. Jyotima Malik to present Professor Mishra with a token of appreciation.
Lot of appreciation.
Opening appreciation and closing.
Okay, 2 times appreciation.
Next up, we have our enthusiastic grad students, Delvin, Pooja, and Dr. Balram, to present to you a glimpse of their research work.
Hello. Good morning, everyone. I am Legend Kulkarni, and I work in the aerosol chemical characterization and receptor modeling lab at IISER Bhopal. So today I'll present about the spatio-temporal trends of the relationships between surface PM2.5 and its chemical constituents across three closest network locations in India. To begin with, it is very important to understand the physicochemical characteristics of PM2.5 as it influences the climate, human health, air quality, and the overall ecosystem. So these are the four major components of PM2.5, that is organic matter, inorganic ions, elemental carbon, elements from soil. If you look at India, there are more than 1200 monitoring stations set up by CPCB, which measures these 12 important pollutants. Coming to the limitations of PM2.5 studies in India, we see a lack of inclusion of these major chemical species and also a very limited number of samples are measured. So to fill this gap and to have a better understanding about the physicochemical characteristics of PM2.5, the carbonaceous aerosol emissions, source apportionment, and climate impact network was found in India, and IISER Bhopal is also a part of this network. My study area covers the Bhopal, Mesa, and Mysore region of this network, and these regions are regionally representative, and also they have very distinct PM2.5 source contributions. So coming to this study, in this study, a mass closure analysis was developed where the total PM2.5 concentration was reconstructed using the major chemical species as explained before. So in this, the major chemical species was captured using specific filter media substrates like nylon for ions, quartz for OC and ECl elemental carbon, and Teflon for elements. Along with that, the volatilization losses occurring from the organic carbon and nitrate ions are estimated. With that, the aerosol liquid water was estimated using various thermodynamic models. At last, all these inputs were fed into a multilinear regression model to determine the annual and seasonal coefficients. Some key highlights of the study: the spatial and temporal variation of the O/M by OC ratio was established across these three sites, where we found the pre-monsoon and post-monsoon contributed to higher ratio. So this resulted from the enhanced seasonal contribution of the secondary organic aerosols. Along with that, the aerosol liquid water showed increased contribution during the winter period across the three sites. To conclude, the seasonal MLR coefficients along with the accounting of ALW and volatilization loss in RCM helped in the better agreement between the PM2.5 and the reconstructed mark. Thank you.
They come to your poster or not to learn more?
Yes, please come to visit my poster. It's at 3:30.
Questions will in the poster, na? Questions will be taken in the poster. No, here only.
so many.
Okay, okay.
Next couple of minutes for question answers.
So, why particulate matter actually we find more in winter seasons only? And what is the reason how it is related to the atmosphere?
Okay, so we don't generally like it's a very debatable question. We don't necessarily find more PM. Okay, so it like there are multiple causes like meteorology, lowering of the boundary layer height, and and also the wind speed. If you see in the winter season, there is very the wind speed is very low. So these multiple factors causes high concentration PM2.5 during the winter.
Yes, we generally see daily polluted in winter seasons. Right?
Yes.
So, what are some factors we generally see winter season very high PM2.5 in winter in Delhi and in that regions?
Factors. Hello. Hello. Factors. Sometimes it's due to the meteorological condition, and also if you see, like we seen recently that there's in the news that biomass burning also affects, and also the enhanced construction activities all around the Delhi, because Delhi is also surrounded by the industrial area, Ghaziabad, Noida. From there, the construction activity pollution also enhances the situation.
Pankaj sir had a question.
Next presentation is by Pooja Tiwari.
Yeah. It's been live streamed in YouTube. Thanks for making me famous.
Hello everyone, I am Pooja Tiwari and the topic of my talk is morphology and applicability as a robust stakeholder. So, studying a temporal relation of rocks is of utmost importance in order to understand its crystallization history in case of igneous rock or metamorphic history or depositional history or provenance history or metamorphic and sedimentary rocks or any geological events it has been seen. However, assigning this temporal framework to sedimentary rock is quite tricky, especially when it is dominated by succeeded sedimentary rocks and devoid of many fossils and all any igneous or volcanic organisms. One such example comes from Finland, especially the upper Finland sequences. And as you can see, this is the certificate chart along with some geological data which has been reported for the Finland sequences. And here also for upper Finland sequence also the geological information has been reported based on the dating of globonite, Gandhi limestone, that is carbonate, and upper Gandhi sandstone digital dating, as well as some alluvial data. However, they are not consistently with each other. Thus, there is still a controversy going on with respect to the age of human sequences. In this context, I have compiled the data from the literature and compared it with my samples for the zero time geochemistry and morphology in order to understand whether it can be a data substitute for the sedentary rock. outgrowth of zero time over distraction and also the overgrowth of zero time over distraction from the limits the same. And this is the drawing of the same overgrowth of over distraction. And as you can see from this morphology and compare with the samples from my study area, you can see it is very clear that these are also morphologically similar. So this is my study area. Bhopal lab, and from to further confirm the morphology of these zero time, the similarity of these zero times, whether they are approximately hydrothermal or English or mesomorphic, I have also compared their geochemical explanation, and here I can see the samples from Bhopal lab are mostly overlapping with the diagenetic field in the combined normalized effect as well as in the trace element bivalent plot. Also, however, in bivalent plot, it is seen that some of the samples are also overlapping with the hydrocarbon field, which can be further confirmed with the concentration of uranium and uranium metal ratio, which is very low at hydrocarbon times as compared to diagenetic. And for the uranium concentration and uranium concentration for gas are similar to the diagenetic membrane from reducer. So from this discussion, I can conclude that the zero time oxidation generation from the study area can be a better substance for the geochronology of the mineral structure. Thank you.
Stage is open for questions.
Nice presentation. So, a simple question that I have is, what are the advantages of using zero time, that is other than zircon, nitride of zircon, and glaucomate?
Well, the title system gives us for sedimentary rocks. The title system gives us the maximum positional areas, not the exact positional areas, neither the nearest positional areas. And in case of glauconite and any other ordinary phases, if we use, especially Gillian is not protozoic anymore. So it has gone through various alterations and changes. So these ordinary phases are prone to later thermal resetting. However, xenotime is very robust with respect to this thermal resetting, and it remains closed throughout any changes. So it can be a better substitute. And
Any more questions? Okay, I guess that's it. Thank you. The next presentation is presented by Dr. Balyam.
Coming up here.
Good morning, everybody. My name is Dr. Balan Tiwari, and I'm doing my postdoctoral studies in the Academy of Dr. Jyoti Murali. So my presentation topic is an outcrop study of Fibers law of morphology and the internal structure of Baker law of flow insights into the CO2 storage potential. So, with the advent of industrial revolution and the widespread use of fossil fuel, the CO2 emissions in the atmosphere has risen dramatically from 280 ppm in 1750 to 410 ppm in 2020. So, as a result of that, the average Earth's temperature has risen by 1 degree centigrade.
upper figure, and also the global mean sea level is rising 1.7 millimeter per year. So this is very hazardous to the climate change, as the countries like Maldives, Bangladesh, and our own Mumbai coastal areas can be flooded with ocean water in the near future if the same CO2 emissions persist for the longer time. So what are the possible solutions for that? So for offer alternate clean and green energy and carbon capture and storage energy, which is widely giving the attention to CCS technology. As in CCS, what we do, we store CO2 in the geological reservoirs such as unminable coal seams, depleted oil and gas reservoir, then save and also the salt caverns. But among these all geological reservoirs, the continental flood basalts gives us advantages because it has large storage capacity, vast area extent, and also the main factor is the low risk of leakage because of the conversion of CO2 into carbon gas. That is the permanent sequestration. Now, coming to India's perspective, our own Deccan tract can provide vast extents of 5 lakh square kilometer, which can give sort of high storage efficiency for the CO2. But the challenge is that Deccan volcanic province so diverse range of lava morphologies, vesicle distribution, and fracture network, which impart challenges. And understanding this heterogeneity is very important to know the variation in porosity and permeability. To address this, we have done a rigorous field study in 20 locations, and we have seen the vesicle distribution, fracture network distributions. So here in this figure you can see we have seen the vesicles which are connected, which are not connected, which are connected, some are connected with small scale fractures. So how it can impact the CO2 storage efficiency. In the first symmetric diagram you can see only few vesicles are connected. In the second and third, most of the vesicles are connected, and in the second one it is connected with the small scale fracture. So this will enhance the CO2 storage ability. Now coming to the CO2 flow, in the fracture pattern we see here, we have seen various type of fracture network. Some are intense fracture which are connected, and some are not connected. So the fractures we are connected will enhance the CO2 flow. Now coming to the three-tier structure, here you can see the upper vesicular zone in the symmetric diagram. There are abundant vesicles, but few are connected, few are not connected. Now, if this upper vesicular zone is connected with the connected fracture zones, in this symmetric diagram you can see it can enhance the CO2 storage efficiency because the upper vesicular zone will enhance the CO2 storage, and the second, the fracture zone will enhance the CO2 flow. So combining both the upper zone and middle core zone can enhance the CO2 storage efficiency. And if it is overlain by the upper massive core zone and lower massive core zone, it will also hinder the leakage. So this field study guides us to select specific storage sites for pilot CO2 sequestration projects. Thank you very much.
Why you know that we are talking about 1.5 degree warming because of CO2. Why we are talking about 1.5 degree and that answer will come from this geological sector.
Because in infrastructure in India also we are using fossil fuel energy, and the 69% of the energy of India is made by the fossil fuel, including coal. 44% of energy is coming from coal only. So this all CO2 emissions is creating the increase in the CO2 level. That is, it has increased from 200 people to approximately 400 people.
1.5 is global.
Yes, sir. Just
anyway.
It's a very nice talk. I have one question. What are the challenges that we can face while doing CCS and technical soil, and how you deal
generally the feel that because of the connected vesicles and connected fractures, if it is not connected, the problem is the variation in porosity and permeability. A few studies related to the porosity in Deccan basalt is done by Pandey et al. So he has shown that the massive variety has the porosity of 5%, whereas the fracture one has a porosity up to 20%, 10%. So there is variation in porosity and permeability. So tackle with this challenge of porosity and permeability. This field study is very important. Also, to make some accurate geological model, you have to accurately feed the exact porosity and permeability. That is the main challenge.
Are there any hazards associated in the long run?
Yeah, if this CO2 emission persists for a long time, so the global mean sea level will increase. Also, the average Earth temperature will increase. So it will melt the permanent ice sheets in the Greenland. It will in turn increase the global mean sea level. So countries like Maldives and the coastal areas will travel in ocean water. Also, we have seen now the frequent weather conditions changing, floods, cyclones, all those things.
I meant like associated carbon capture after you were capturing this data.
Yeah, so
are there any hazards?
In case of unminable coal seams and depleted oil and gas reservoir, so some sort of leakage problem is there. But in case of CO2 storage in basalt, so the cations present in the basalt, when it is reacting with the CO2, it will permanently form the carbonates. So in the Valula, USA, and also in the Iceland Carfish project, they have shown that CO2 reacting with the basalt is creating carbonate, means permanent sequestration. There is no risk of leakage. And also these basalts are having the harsh expansion, Deccan trap, Siberia trap, Columbia river basalts. So you can mitigate permanently this CO2 from that.
How does your storage different and what the time for the reaction?
So in the case of Valula and Iceland, they have shown that within a time frame of 1 year or 2 years, CO2 is converted into the carbonates. So this is the time frame, almost 1 to 2 years in the Valula and Carthage in Iceland. Sorry, in Iceland and Valula project is in US. They have shown the time frame of 1 to 2 years. And it is permanently sequestered and forming the carbonates.
So you know that when carbon dioxide dissolves in water, right? And then you react with rocks. So you produce actually bicarbonate, not carbonate.
So further, actually, basalt, the phosphorite polyins, they supply the divalent cations like Mg2+, and in the further reactions, they react with the H plus ions to form the carbonate. There are a series of reactions starting from these CO2 plus CO3, then divalent cations, then finally forming this.
See, in reverse, you produce bicarbonate, not carbonate. The same reaction you are supposing that it will happen subsurface.
Yes, sir, it is already proven in two pilot projects. One in I told earlier, USA, the project, and the other one is Saturday. So we will look into that the clinical lessons in that.
So I have a question. So how can we identify these leaks? How can we identify these leaks in the pipelines?
Pipelines, that is pipelines. That is the
pipelines when the transport of the
that is the further process. We just are dealing with the geological problems. So that is the industrial aspect. We do after the pilot project is established, then that is the problem.
One more thing.
Yes.
So when you are producing bicarbonates,
Yes.
and from bicarbonates, again, because of depending upon the saturation index, you produce carbonates,
Yes.
right? During the carbonate precipitation, again, CO2 is formed. So you are trying to remove CO2, but you are still producing CO2. So how do you take into account that product?
Yes, so that we need to address in the future.
Moving on, what is the most engaging thing to witness if not controversies? To bring the critiques out of the critical mind, I would like to invite Dr. Jyotima Malik to chair a debate on whether site-specific studies help ground-truthing synopsis to global scale studies in geosciences.
Okay. Can I have that mic here? Okay. Okay. Good morning, everyone. So, I completely forgot it's so long, the debate title. It's very difficult to remember. Right? So, what it essentially means, can you put the debate title so that we can refer to it while we speak? And I have said that I will chair this session only with the hope that every one of you will contribute. Okay? I'll just start and then, it's on us to actually continue and engage for next 1 hour. Yes, sir. So that is what I am going to do in a moment. Hand it over to sir. So, as the title suggests, can site-specific studies help ground-truthing synoptic to global-scale studies in geoscience? So, rather than getting into the debate, I will tell you from my experience the type of data which I work on, how that particular problem is tackled. In most of the cases, I think we do not really have a choice but to actually take that strategy. That you have a few data points, and from there you have to interpolate for a larger area. So I will give you example from oil and gas fields. What happens there? Suppose you have a field which is 20 square kilometer aerial extent, right? And then you have in that particular field 5 wells. Wells means small holes which are drilled inside the ground, and they can be pretty deep, up to 3 kilometers, 4 kilometers. However, the width is 3.5 inch, right? So if you think about 20 square kilometer, and out of which you have 5 wells, which is having, so the data that you are gathering from the wells are really hairline. We call it hairline data, right? So you have a very large area, and where you have 5 places where you have site specific data, very high resolution data. However, the aerial extent is really limited. Now you have to make a model of the whole field from those 5 wells, and such a problem we are discussing right now. So what is important here in case of oil and gas industry, you do that you correlate your high resolution data with some low resolution data. And the low resolution data in this case can be seismic sections or seismic volume. Right? So seismic maps, you have, say for example, seismic driven porosity, and then you have oil driven porosity. You try to match them, and then you try to create a reservoir model. Now, one important thing here to address is uncertainty. So uncertainty actually makes and breaks that game. So you might be able to actually make a model of a very large area with a very only one single data. However, you have to make sure that you are recognizing the uncertainty and you are actually documenting the uncertainty in the most efficient way. So as the number of data points increases, your uncertainty will slowly go down. So I think that is essentially the heart of the matter, that it's important to address the uncertainty where you try to uh, you know use site specific studies to talk about global systems. So with that introductory remark, may I say Professor Tandon if he has some remarks on it as well.
I get used as is this on? Can you hear me?
It is on.
Can you hear me? So I get used as a jack of all trades, master of none. Uh, yeah. So site-specific studies. I don't know. I mean, I've been caught off guard, and I have to think of something quickly. But my mind went back to some kind of exposure I had once at the Max plant in Jena, from where she comes, Danya comes, and they were producing a lot of papers actually. There was a Argonauts team calling somebody British and Sandy Harrison, right? They were leading that group, and this was about looking at lakes in Sahara, and then talking in terms of integrated climate systems. And they were largely covering the period of the last 7 to 8,000 years. So, I mean, how Sahara went through multiple greening episodes through time, essentially. And almost a paper a month. If you look at their board, they were kind of stuck with pins. So people, very impressive, that you could kind of. But then they were running models actually. So you were looking at the models, you were doing the Sahara, this thing, looking at the mass transport across Sahara and the history of this thing. So at the synoptic scale, the very quick delivery was there. Now, the reason why they chose Sahara was two examples I'll give you. This is the first example. The reason why they chose Sahara was that there are a lot of lake studies. In Europe, particularly France and Germany, have had a tradition of looking at Saharan lakes. And lakes hold the clue for paleoclimate. So, your site specific data, so there's the possibility of model and then the validation of the model from those site-specific data. So they would go from the model, have a model run, look at what lake levels should have been, go to the lake essentially, see if it has already been done, and at that time slice, see if there is a match for a mismatch, and then come back and tweak the model. So I think the answer is very obviously yes. I mean, the answer cannot be no to my mind. So that was one example that came to my mind. Then you look at these kind of data to the other thing that I am noticing, I mean, is I was reading something very interesting in terms of how there was a question that was set up, and I think about 3 years ago there was a paper in Nature which said mapping the free flowing rivers of the world. Right now, what is a free flowing river? The free flowing river. I mean, first let me tell you what a free flowing river is. They claimed that most of the rivers of the world now stand disconnected. What used to reach the sea essentially, now only 23% of those rivers reach the sea. And 67% of the rivers of the world, after human interventions, have stopped kind of free, they don't, I mean, like damming, free flowing, they're no longer free flowing essentially. So, and the 33% that remain essentially come from, the 33% that remain come from areas like the Amazon domain or Siberia, where man has not kind of gone and infringed there essentially. So that, of course, is now leading. So what happens now? If you think in terms of Bayesian scale, how do you kind of transpose those? Well, this is data that is coming from global databases, right? It's part two of the system, synoptic to global scale observations. This is coming from there, right? Now, there are very few institutions in the world which are actually monitoring or having satellite systems which are looking at rivers almost continuously, real-time data, like Colorado actually. Colorado is one place where, the Colorado laboratory, headed, I don't know by whom now, by Sivitsky at one point of time, is the lab which is doing that. So this integrating the site-specific information with these synoptic scale. So these were two examples that came into my mind essentially, because as I said, I happen to be a jack of all trades, and I kind of quickly tried to think of from my own reading list, what can I say about this? So I think these are the two kind of situations. To my mind, the answer is I would, if there were two teams here, I would join the team which said the answer is yes. I am not with the naysayers. So I am very firmly with those who believe that the answer is yes.
Thank you, sir. Yes, Gaurav.
Yeah, so I can add one point here. I'm not against Professor Kannan. I also join hand with him. There are two parts I can see here in this title. Can site-specific study help ground truthing synoptic to global scale study? Generally, yes, but it depends. Site-specific, when you say what is the range of data you have. I'll give you an example of very open question. Still, that question is open. What sets the width of an alluvial river? We don't know so far. But if you see that knowledge comes, that was discovered in 1932. So that comes from an empirical study which was conducted in India, Ethiopia, and some African country. That says that if you make measurements, width of a river, any river, a scale as a square of discharge. That holds true. Wherever it doesn't matter in which climate setting you go, that relationship holds true. Now, this observation, this empirical observation, tells you that something is there because it's not so uncommon. If you're getting some random behavior, of course, you will not go and say site specific can help us to understand the overall picture. But here there is something. If that measurement tells you universality exists. And now your objective is if you can explain that universality, why this holds true. Do you know can we explain this empirical relationship? If you can find solution by using any kind of mechanistic theory, physical reasoning, yes. Your empirical observation can be generalized to any object. Okay, so there is a recent paper which was published in PNAS, and we also published one paper in 2022 about the scaling of Himalayan system. So earlier people were saying all the Himalayan rivers behave in a different way. We said no, all they behave in the same way. It doesn't matter wherever you go. If you have a measurement from alluvial system, let's say in Kosi River, Ganga River, that can be scaled. Okay, so my answer is first see the trend. If there is some universality, yes, site-specific things can be used to explain global things. If not, then don't put your mind. Say simply your data is this. Thank you.
Okay, sir, please.
I think yes, because if I say no, I won't be able to do many things besides. So, but I think answer is yes, because we have limitations, because we cannot measure the process everywhere we want to. Remote sensing has helped, but still remote sensing has limitations to measure what we want to measure, right? So I will say, like, if you want to diagnose this little further, you should think of about the processes. how small scale processes are related to large scale phenomenon. So first is, let's say tree ring data. If you don't know tree ring data, we can use tree ring data to have the proxy of value of time. Okay? So tree ring data, even from one location, can tell a lot about whether the climate was dry, wet, or what kind of climate was there. Because it directly connects with a very large scale process. The other example I can give you that contradicts, let's say water quality. Water quality of a lake or water quality of a stretch in a particular river, if you use that data, it won't tell anything what is happening at a larger scale or global scale. But at the same time, if we think about water temperature in lakes, again, that could be a representation that can connect directly with a large scale process like climate warming. So you may find lakes across the globe that water temperature is rising, but not in terms of water quality pH. Probably would not give you a very good indicator. So I would say yes, answer is yes, but if the process is what variable we are measuring is connects with a large scale process, then the answer is yes. If it doesn't, then the answer is no.
Thank you, sir. We wish to hear the opinion of the students as well. Anyone? Come on. It's a debate of the audience, not only the faculty. Yeah, they have written debates. So anyone, any student? Yes, go ahead. Introduce yourself as well. Yeah.
Good afternoon to all the faculties present here and students. Myself, Vaisi, and I'm currently working in the fluvial geomorphology and remote sensing lab. And so, talking about this debate, I would like to present my views in favor of this topic. Yes, we have the limitations as well. But, like, if we starting with the data collection on an on-field basis, it is very obvious for every human that we can only cover a very small scale when we go on the field calibrated measurements. But field calibrated measurements are also very important when we want to do a very robust study. We are all going towards advanced remote sensing techniques and technologies because they help in studying about the wide areas. But they also have their own limitations. Even many of the robust models we're trying to work towards increasing more and more, producing more and more good models for producing better results. But still, we are on that path. We have not reached good 100% working, good effective models yet. So I feel that even conducting a good small scale study in every region. For example, since I'm working in the fluvial part, we can't go and conduct field measurements for large rivers. We can only cover a small reach or a stream, and we can collect data from there, and we can see what are the results. Maybe we get very good data, and we can rely on that, and we can specify it or verify it with the other reports or other data that have been published. So, and I think that really builds the foundation for the further studies. So I think the small scale studies are equally important on a global perspective, but yes, we need to look at many factors as well. Thank you.
Thank you. This is not working. But I am loud enough. Fine. So anyone else? Nobody spoke against it. Anyone dares to? Yes, yes. Inza, go ahead.
Good morning, everyone. I am against this statement actually.
Okay, we have got one. Yes.
I will use a simple analogy. Uh, if we see an elephant, right, from the very in front of it, we see elephant like it has only a trunk, nothing else. We can see nothing else. So from a only a perspective, only a small scale study, we can't say about the whole body of the elephant. Same as like for the Himalayas. Okay, so in case of Himalaya, we can say like overall there are different scale studies for Himalaya. For large scale studies, they are very involved, and small scale studies there are different faults. So the faults process in different mechanism, and the blade collides with different mechanisms. So if we study a fault and we connect it to the plate scale phenomena, then we can connect it. There are two different mechanisms for these two different studies. So for me, this statement is not correct, and yeah, it could be correct if we can connect the small scale different local different locations small scale study, and if we can connect this study, then we can connect it to the global scale studies. That's my view on it.
Good. So,
Can I pose a counter to him?
yes, sir. Please.
Even I would like to counter.
Oh, he's supervisor wants to count. Okay, great. Now we are getting in the debate mode.
Pro and against. If I don't go against you, then see, you said what you said. It makes sense to me till a certain point. But then, if you look at the MBT, if you look at the MCT, and you look at the MHT, ultimately all of these go and merge with the mantle thrust, right? And that becomes the plate scale phenomena. And whether you look at MBT or a splay of the MBT or the HFF or a splay of the HFF, we are ultimately actually going to the plate scale. So there is the possibility of linking a splay or a set of splays and crossover from one scale to another scale to another scale till you get to the plate scale. So there is the possibility of integration. So therefore, I would still hang on to my view, despite your courage to say no.
Okay, we.
I mean, this is just to build up some spice.
This has two audience, so I don't know why.
It's okay. Am I audible? No.
Yeah, you can use this.
Okay, so thank you, India. Although like you work on something which supports this. So essentially, what I feel that for my own work also, I completely agree with this with Charan sir, with Professor Mishra, with Gaurav also. I guess that depends on the problem you are choosing. The kind of problem you are choosing, if it is on a larger scale, you can actually you can choose the sites which may address and be correlatable to your problem at the larger scale. But it may or may not be actually the same when you are choosing a problem at the smaller scale, and it can go all the way to the larger scale as well. So it's a both ways, but for your work, essentially, I can say that he is going to present today. And so all of you are invited to this poster. Where so coming to like Karan sir, like what he said that you have MBT and CT and everything that can be connected and we can study at the bed scale. For example, if you are interested in studying a bed scale Himalayan deformation, then you have to work in the out of sequence thrusts, which is actually feeding into your Himalayan wedge and its critical stage. So that in that way it is connected. But if you want to go a reverse way, that it may or may not be. So it works both ways and it based on your problem.
Yeah, but my point is like we can study a small scale phenomenon like the out of sequence. That's a very small scale phenomena with respect to the whole Himalayan. So only studying out of sequence thrusting or a simple play as but we can talk a whole scenario about the Himalaya, right? We can only talk about this only particular. May I add something? Yes, sure. But the underlying physics is same now for optical system. See, that you can expect same underlying mechanism in Himalaya in any other orogenic field, right? So in that case, if I gather some knowledge from Himalaya, I can apply that knowledge in any other mountain. Yeah. So it's actually based on your problem, what are you trying to do, and based on that, you can actually say yes or no. So now, if you analyze any geochemical composition of any river system, you cannot compare it with this another continent. No, but we do. Last.
I'm quite sympathetic to your judgment, Prinza. As a young PhD student, I used to also think like you. But however, as you mature yourself with studies, you will see that there will be data and there will be data gaps, and there will be no choice but to interpolate between them. And how well you can interpolate them with logic, I mean, that is where your science will be based on. And as I said in the beginning, analyzing uncertainty is absolutely important.
There are lots of
Yeah.
uncertainty with that if a small scale
Absolutely,
study,
absolutely.
is going to the large scale.
As long as you recognize, document, and analyze that uncertainty, quantify that uncertainty to some extent as well, I think you will be in business. There is one comment from.
From the minimal work that I have done during my PhD, I would stand and say yes, exactly. Because on the basis of two or three samples of a sandstone or a quartzite, people have correlated like supercontinents like Colombia and Rhodesia based on 100 zircon grains from a small sandstone sample of a 1 kg or 2 kgs. So I would probably say yes. But yes, there are caveats. That is, the real confidence only comes with a lot of studies. So it's not just one study. With one study, you will say there was a continental crust of 1.8, for example, somewhere near to the, I mean, in the provenance. But as more and more people work, the data sets gets larger and the gaps are filled. So that will give us more confidence.
Absolutely, I think I can relate to what you were saying. Sir will also agree. I mean, we discovered one Dickinsonia fossil in Bimbetka, and we said India was at 500 million years before. So that is also one way of looking at it. I think, and then we were proved wrong, right? So I think one of the things we have to be very careful while we do such interpretation of a global scale from a point scale data source. Satinder sir has something to say because yeah, last because he brought up this point, so he has to speak it. नहीं आप बोलिए हाँ of course.
Okay, so when our team was asked to put up a question topic, so actually we searched a lot, and when we couldn't find something important, so I thought probably, and we discussed and we come up with yes, we can put up as a suitable question at this platform, and yes, of course, because this question is very important because when we look at the type of expertise we have in our department, right? So most of the people they work mostly on the large data sets, and then there are groups who have very limited data, and that too they have to produce. So they have to go to the field, put up a lot of hard work, working in very sophisticated instrumentations, and then come up with only a few handful of numbers. Right? You cannot even fill up sometimes even one page with a data table. Okay, so that's the kind of data we work with. And I become very happy when the question comes to report because it becomes very difficult for me to say my a very limited set of data indicating that yes, what's already known.
and when it already supports the existing information. So any geochemical or isotopic anomalies that I find and that I'm able to explain, it gives me immense happiness, so that people believe in that, yes, the small scale studies and with a very that much after putting that much effort, 5 6 year student puts in, and then come up with only handful of numbers, only one or two plots. So you understand that sometimes it becomes very important that it should be published. And while publishing, sometimes, of course, everyone looks at the data differently, and there's too much of iterations, and ultimately we publish, and it gives us happiness. Yeah, that's it.
Thank you. We have one comment from Dania as well. You want to support him. Very good. Inza, you are being more and more support.
Various BA students there.
Yeah.
Okay, so I'll start with some kind of historical mistake we did. So when we had this greenhouse gas observation that was started from by Ralph Kill, so everybody was using that time series. Still, we use the time series to say about the global trend of greenhouse gases and so on. So when that Monroe Observatory greenhouse gas CO2 specifically, when it is used, and some studies they came up with some conclusion saying that northern hemisphere is a source and the southern hemisphere is a huge sink of carbon. That means the greenhouse gas is being like deposited in the south region, and northern hemisphere it is getting produced. So there are a couple of papers. I'm not talking about small papers. I'm talking about science and nature paper. They're claiming that this is huge, sink and so on, and then came up with Amazonia regions where you can see source and also sinks. And so the problem that happened there is using one site data or two site data to tell about the global problem. So I would argue that there is no harm in using site-specific data or site-specific studies, because this is what we want. And people who knows me or who are working with my group know that we use a lot of observations, and we also click for why there are not site-specific informations and so on. But the point is whether you represent that specificity correctly or not. If you do not represent the specificity correctly, then you end up with same global problem totally in another way. So it is a systematic error will get propagated, and you will see a different thing. But how that can be addressed, this is by increasing the density of the site-specific data or site-specific studies. So, conclusion is we want site-specific studies. At least for my kind of research, we need site-specific studies. Unless that is being utilized, we may end up with a very smooth function, which is not how the nature functions.
There is one comment from last comment from Ashish, and then we will conclude this debate.
Yeah, people are talking from.
Why are you sitting in the last bench?
So that everybody can see me. So the point is, everybody is talking from science point of view. I mean, I want to bring some fun here, okay? So, I mean, if I try to relate to his comments, suppose we are like studying elephant, right? And then we are studying one part of the elephant, right? Now, how will correlate? We also have to understand the tactical reality, okay? The reality is, nowadays, like suppose there are hundreds of research groups they are working, so all need to survive.
only to publish. Okay? If there is one group and if there is one technique by using this technique, like one group is doing like, okay, show everything. Okay, so then other group will die, right? So instead of doing that, let's say 100 group is studying 100 grids, and then like, okay, one big group is connecting all these 100 grids and to make it or to generalize it. I mean, that can be also one way, right? Sure. Yeah. I mean, that was like a fun part. I mean, for our own survival. Okay. So now coming to serious note. So relating to my research, okay. So I work with like, okay, environmental geochemistry. Like, okay, let's say if I take example of arsenic problem, so we know that okay, arsenic problem is like, okay, I mean it's very severe in Bengal Delta, or it is like, okay, in the whole Southeast Asia. So and if I want to, let's say, characterize like, okay, how arsenic is present in aquifer sediment, okay, so how it is getting released. I mean, of course, it is not possible, like, okay, for me to collect, like, okay, these aquifer core from everywhere. So what I am doing, like, in an area, I am collecting from, like, one very particular location that Jyotirmoy, he started with, like, okay, hairline, let's say, data. Okay, but then basically we are trying to correlate it with like, okay, the regional the findings, or I mean for the all over the place. The point is, so I mean both approach has their own advantages and disadvantages, right? So if we want to make regional study, of course, like, okay, the resolution that we have to compromise with that. Okay. And then if we can do a very site-specific study, we can have very high resolution data. Okay, we can have very high resolution data. And then, like, okay, if we have such high resolution site-specific data from multiple locations, then basically we can correlate. So, and then my personal opinion is like, everything is very ordered in nature. Okay, so because everything is happening, right? Like, okay, so in an orderly fashion. So what we are doing, so even like, okay, arsenic problem, in some area there is no arsenic problem, in some area there is arsenic problem. There must be some reason. I mean, nature is controlling that. So what we are trying to do, basically we are trying to identify those order. I mean, how this process, they are taking place in an order to have at one place arsenic contamination, in another place no contamination. So it comes from the detailing. Okay, so I mean, I want to emphasize particularly the detailing of the work. Okay, so that like, okay, I can characterize like, okay, the process what is happening already. I mean, I am not doing anything new. Just like, okay, what is happening, I want to characterize. Yeah.
Okay, thank you, Ashish. I think let's give a round of applause for those who have participated in the debate. Yeah. When this topic was brought, I did not really think that, I did not really anticipate that we can spend so much time, but thank you everyone. I mean, we all enthusiastically participated. So I think we can close it now and we can move to the next topic of our program. Yeah.
Thank you everyone for your enthusiastic participation. Special thank you to those who went against the topic. Indra, Ashish sir, Dhanya ma'am, thank you.
But you forgot his name. He started.
Exactly. Okay. Next state of science presentation is presented by Omkar Reddy.
Hello, is now audible?
Hello everyone, I am Omkar Tirke, and before starting my talk, I would have made a collage for you guys and presented a set of pictures, and I would like to think about. I'll ask you guys to think about these pictures. So the first we start. These pictures represent the different life spheres: hydrosphere, atmosphere, biosphere, and the lithosphere. And you can see that in various forms that our world has been shaping very differently. And what these are the things that we are seeing, that the marine life is being getting strained with strangled with the fishnet. We are releasing lots of air particles, pollution, pollutants in our atmosphere. We are doing lots of mining to get the resources and minerals. And for that also, we are changing our landscape, the soil profiles, the mountains. We are taking down the mountains and everything. And the levels of pollutions, the humans have made such levels of pollutions that the pollution is also reached at Himalayas, the third pole of our, the third glacier pole on our Earth. And humans, since they are also trying to find out various methods for energy production, they are still not able to figure out one big problem, like how to handle the nuclear waste that is being generated out of the nuclear energy. Deforestation is going on, and again, the level of pollution has reached so much that even we have come to space pollution, where the debris from spacecraft, aircraft that we are sending into space, it is being accumulated into the space. And this all things altogether lead to a conflict in society, lead to a conflict in human population, which we can see that there are so many war crimes are happening because of various geopolitical reasons. And we see that due to whenever there is an instability caused by humans to the nature, it is directly reflected back to our society and directly reflected back to our human population in one or the other way. And so, what do we think of it? Because over the future, as we see, we had dinosaur fossils coming up when we dug out. The future generations, when they dug out, they'll find plastic bottles and like pollutants, and no, and that would be the trace, or that would be the legacy that would be keeping ahead. And that's where I'm taking you. My topic for today's presentation is Anthropocene, Earth's Epoch of Humanity. So, humans, since when they have arrived on Earth, they have started making changes to the Earth's systems, and that has profoundly impacted all the cycles that work on Earth, all the ecosystems, all the biodiversity. And we'll be seeing in this talk. So, first half of my talk would be focusing on what is Anthropocene, what is the concept, how it was formulated, and then the second talk I'll try to convince you guys on the level of ISA B perspective, what can things we observe and what can be done to change it. So anthropos and scene. So the word welcome to this Anthropocene era. So Anthropocene is made of words anthropos and scene. Anthropos of course means humans, and scene is the new time that we are coined. So this word was coined by Paul Crutzen, who was the scientist, and so it's not the first time that this person coined the term. There was already a concept regarding it, known as noosphere, that the world is now being handled by a consciousness. Before, all the animals that we were seeing, which existed during the ancient times, they didn't necessarily have the consciousness. But with the advent of humans, we see that we have our own consciousness, and with our own thinking and with our own mind, we are able to change and formulate things according to our own will. And Anthropocene has been such a popular term that it has become a global lexicon similar to DNA in such a sense that even if our current semester courses, all the three or four courses that we have been taught mentions Anthropocene to a smaller extent. And that's why studying Anthropocene is something which is very important for us. And why Anthropocene? Because it's kind of geology of mankind. Earlier, the tectonic processes or any of the geomorphological processes, they were essentially the natural processes. But now humans have altered all these processes to such an extent that they have kind of indirect control over all these processes. How this idea of Anthropocene came into being? So it started when scientists started looking at the
signatures of carbon dioxide and methane in the ice cores. So basically, through geochemistry, the use of geochemistry, which is used to study like the Antarctic shells and everything, we use geochemistry to date the shells cores and get to know about the past records of our atmosphere, which are preserved in those shells. And similarly, during the study, the we scientists could find the increasing level of carbon dioxide and methane in those ice cores, and that's how we could say that okay, now humankind has actually started having an impact on nature, and it can be actually traced back to some of things. Now coming to Anthropocene, it's still an informal epoch. It's not formalized or not accepted by geological time scale, and it's just a small meme, and it is an debate among scientists whether it should be formalized into an actual epoch or not. So an epic debate and epoch debate. So journey through history, evolution of Anthropocene. As humans have gone through evolution, the idea of Anthropocene has also gone through evolution. It has been through many other changes, and here is a brief summary of it. So, how of Anthropocene? Like, how did we even find out what Anthropocene is and what the idea of it is? So, I already mentioned that scientists started saying that there were already alterations to biogeochemical cycles being observed in the nature profiles. Ozone hole was taking, like we could see that ozone hole formation was taking place, and various other major impacts on nature we could actually see, and the impacts on humankind could actually be felt. And that's how the concept of Anthropocene came into being formalized. Then why of Anthropocene? Why do we need to study of Anthropocene? Because you, as I said previously, humankind has become a geological force. It is transforming all our spheres. Like we are taking up lots of land in form of minerals and those, transferring and shifting it to some other places, and making untangible changes to the making tangible changes to the full of the ecosystem of the earth. And the thing with this is having a huge impact on the pristine and the delicate ecosystems of earth which actually exist, such as Amazon rainforest or Western Ghats, etc. Coming to the timing of when of Anthropocene, this is being a matter of discussion that when does the Anthropocene start. So I'll be showing you further slides, but it is speculated that when advent of Homo erectus, when the humans started, not humans basically, humans is Homo sapiens. Before Homo sapiens, there was Homo erectus, and when Homo erectus started using fire to control it and to use it in manipulated its own ways for the beneficial of ourselves, we started to seeing a evolutionary trend where our brain size capacity got increased, and we could have that consciousness where we could use any of the material, manipulate it to our own benefit, and use it for our own survival. So here is the great acceleration, which actually mentions Homo erectus is something which happened around 1.9 to 106 million years, 1.9 million years ago. But then since the advent of Homo sapiens till 18th century, 18th to 19th century, we actually see there was very less impact by humans on the whole ecosystem. But then as we proceeded through industrialization, we started seeing many new inventions, whether it be printing press, whether it be use of different machineries, electricity, bulb, etc., etc. We started seeing that it would have eventually a negative impact on full all of the ecosystem, and we can see it in the form, for example, if you take water use. So water use started going accelerating very hardly because there were lots of human population was increasing rapidly. Water was being used in great quantity. We started seeing number of dams built increasingly, and because of that, we could also see that the number of floods and the frequency of floods was also increasing. Another thing that we can see after 18th or 19th century is the advent of globalization, and the marker or a study for it is that the McDonald's restaurants, the number of outlets that has been increasing over all over the world, is a can be a pointer to study how globalization is increasing and how it is negatively affecting our Earth. So how many of you guys feel that how many of you guys feel sleepy when it's around 10 to 11 o'clock and you just want to go bed even if there's smoke? Like you guys must have your own biological clocks, and that biological clock is in biology there's circadian rhythm. Similarly, there is a biological clock for all the species on our Earth, and there is a clock for Earth itself. So Earth works on a cycle, whether it be melancholic cycle, rock cycle, or other cycles, and all these cycles actually come together and function together to form what life to give a flourishing life. But what has been happening is that humans are altering all these ecosystems at very faster rate than they can be actually replenished. And since the replenishment time, for example, monsoons, we are seeing that monsoons have been getting delayed and delayed for longer period of time. But all the species which exist in Western Ghats or which exist in northeastern India, they have fine-tuned their biological clocks, whether it to be for the reproduction cycles, their spawning cycles, or whether in plants for bearing fruits, for dispersal of seeds. All these have been fine-tuned to the actual weather system. But because of the human impact on the atmosphere and the impact on Western Ghats, monsoons are getting delayed, and because of that, all these organisms face difficulty in carrying out all their life processes, which eventually leads into their extinction. So here we can see how all the three things, the consumption of energy, the number of dams increasing, and the number of actual fertilizer is directly correlated to the population of Earth. And I'd like to show you one important thing here is that between 18, like from going to 1 billion to 2 billion, it actually took us around 120 years. But same 1 billion from 7 billion to 8 billion, we actually did it in 12 years. So the number of population is actually increasing at 10x speed right now. And because of that, to meet the global demands of human population, to meet the water demands, we are building lots of number of dams. Again, building dams has their own ecological impact because it stops the sedimentation. It increases the sedimentation rates in the before the dam area and decreases the sedimentation after the dam. It also is regarded to cause floods in the places where the dams are built. Even the fossil fuel consumption, which has been increasing dramatically after 1850, the use of fossil fuels actually releases greenhouse gases, which again leads to global warming. And even the nitrogen, phosphorus, potassium, NPK fertilizers decrease the overexploitation and overuse of this fertilizer actually decreases the soil fertility and it affects the soil microbiome of the land. Now, saying that all of this is just caused by humans is very wrong because there's actually a global divide present between the resources being produced and resources being consumed. So we can see that in North America and Europe, even though the number of population is less, the number of energy and materials used actually is quite higher side when compared to India and other developing countries. So there was this research study done that said developing countries like India and China actually account to 80% of world's total population, but in the total CO2 production, it's only 20%. Even the 800 million people which belong to underdeveloped countries account for less than 1% of carbon dioxide production. So, from this data, we can actually see that developed countries are the ones who should actually take up measures to reduce their carbon footprint and to make a greater impact on the climate. Here again, I am shown two ways by which humans are having a bad impact on our Earth. One is in oceans, the issue of sea bottom trawl. So trawling is a process in which fishermen catch fisheries in very huge amounts. This actually hampers the corals, the organisms, and the fishes which actually live near the sea bottom levels. And it actually also changes the chemistry of the seawater because all the sediment gets uplifted and the aquatic chemistry gets changed. And due to upliftment of sedimentation, the light penetration becomes lower and the photosynthesis that should be carried out also dwindles down. which leads to again huge impact on the aquatic foodways and food chains that occur there. Then there's mercury pollution, which you also have seen in the form of Ikaika disease in Japan. Then ocean acidification, and then killing of sharks as keystone species, which again hampers the whole ecosystem.
Omkar, please try to wrap up.
So again, here is table of how species are getting impacted. Like more than 44,000 species are threatened with extinction. This is from IUCN. And then the ecological threat report and how we are crossing all the barriers. One point I wanted to mention here was ecology and economy is directly linked with the political instability. So we can see in very many places, just like Syria or in places where political instability is always there. It is always due to some of the ecological shifts. So even when the Syria war was happening, there was a food drought there before caused due to some storm, and which led to political instability in the Syria. So that's how this all things are correlated, and we should always strive to have some kind of connection and some kind of equilibrium between all these three areas. Changing landscape. Now I wanted to show you an ISRB perspective. So even in ISRB we see lots of things like this. For example, even now we see uneven rainfall. Then there is due to deforestation, like trees are being cutting down in the campus area. We have seen lots of reduction in avifauna and flora, which is actually endemic to this campus species. And we have seen like there used to be many bird species 2 years back, which we can't actually see even now. Then we always complain about fog in Aksar Bhopal. Fog is one thing which actually should happen in northern parts of India, and it is kind of limited to Delhi. But we have now also seen that fog, even in our campus study, there was huge amount of fog. And then other things that I have listed down, I wouldn't go. But all of these things at the end come to the development conflict. So there is this concept of conflict. Conflict which arises because of development. So for one population, something can be important, but for the other population, the same thing can be same thing can be not good for them. So what is the future ahead? As I said, we live in Anthropocene, and this whole slide must have put you in a very bad dilemma that whatever we are doing is actually having a very bad impact on our Earth, the Mother Earth. But we shouldn't worry because we should be happy that it is Anthropocene. Because what? Anthropos means humans, and humans have the again ability of consciousness and thinking. And since we have that ability, we can also restore the actions which were caused between last 2 centuries back to the previous set where we can have a more sustainable future and more sustainable world. And how we can do it? We as the earth scientists here in ISO Bhopal, I feel we can always look out through ideas which can actually help us with we here lots of people here are scientists and faculties whom I haven't thought about and my students like my student friends too. So I just wanted to say that we can always come up with ideas. Our research can always focus on how to solve real world problems, how to approach things sustainably. Faculties can always incorporate sustainability in all of their courses. Even students can, in the research projects and teams, try to work on something which would actually be used as an application to solve the problems that our world faces. And that's it. Thank you.
Thank you, Umar. We are open for questions.
So I have a question regarding the fog and ice. Is it due to pollution or is it just a natural phenomenon? Because it does not seem to be like smog which is found in
So the
cities.
fog in Bhopal is not actually smog. So we can't directly say it is a pollution related phenomenon as they have said out London smog or the Los Angeles smog. But this fog, when you see through the reports of last 20 or 50 years in Bhopal, fog wasn't something which was common in Bhopal. I think the faculties can support me maybe on this fact. But this I have derived from one of the talks by Saurabh Gopi sir, which he had mentioned about that fog was never common I mean, it's very non. When we look at it, Bhopal lies at the Tropic of Cancer, which is near the equator. So technically, as a fog, it is something very unnatural that would occur in Bhopal. But nowadays, we have been seeing consistent fog occurring for last few years, which has been increasing in its intensity and the number of times it occurs also. So it is definitely related to long-term weather cycles that are occurring, but I wouldn't say it's related to pollution.
Okay, so it is mostly due to climate change.
Climate
and
change.
It is not normal. Right?
What is uneven rainfall?
So uneven rainfall, so even
But you're talking about campus scale.
Wow.
campus scale as in
No, you're talking about campus scale or something else when you say uneven rainfall.
uneven rainfall. I mean, even when I have stayed on campus, I have seen that rainfall occurs in campus even during sometimes during summer or late winter.
Uneven or unseasonal?
Unseasonal. Sorry, sir. Sorry
We
for
thought
the
it's raining only in
Temporal
83, but not in main building.
Yes. This is for airport and India, not everything.
sorry for that.
The uneven rainfall happens in the city of Bhopal, city scale. I mean, I have seen rain in the main city, but not happening in campus.
Well, that is
Uh,
expected.
that is
Convective
expected.
rainfall, you don't have to worry about. He meant unseasonal.
Unseasonal.
So you showed one of the diagrams from Bill Steffen's. Go back one or two slides. Where the glacial interglacial.
Last night. Hotter.
Hotter.
Last.
Yeah, no, yeah, this one. So can you explain this? This comes from Bill Steffen's this thing.
Yes, sir. Definitely.
Yeah, Steffen et al. So this is a PNAS paper. Can you explain this diagram?
So what I had read in the paper was that basically Earth usually
You
goes
start with explaining the glacial interglacial limit cycle. Unless people know that, the rest won't follow.
So glacial, I was coming to that only. Earth goes through something known as Milankovitch cycles, which involves the eccentricity of the Earth, the periodicity of the Earth, and the precision cycle of Earth. So what is basically precision cycle is Earth is basically just like a top, the bhora that we used to play, and the axis of the Earth keeps rotating or tilting at some constant rate known as 26,000 years, which is also responsible for changing of our pole star. Currently it is Polaris, but at some time it was Vega, and for other time it was also Thuban. So every 26,000 years, because of precision cycle, Earth's climate also changes because the amount of sunlight received dependent on the precision is different. Now about glacial and interglacial limit cycle, Earth goes through cycles of periods as glaciers where most of the Earth is covered through glaciers, and if full Earth was covered through glaciers, it is something known as snowball Earth. And then there are time periods like which we are living in now, which is known as interglacial cycle. This time period between two glaciers. What is happening basically before Holocene, what used to happen, the glacial and interglacial cycle used to be cyclic or periodic, that they used to happen at similar amount of spacing or time. But once we have crossed Holocene, it has almost been 10,000 years that we have not seen the glaciation, like the glaciation cycle should have been happening now, but because of the global warming and the ambient rise in the temperature of the atmosphere of Earth, the glaciation is not proceeding, and the glaciers are actually retracting from their paths. There were also images which showed that the parts of Greenland which used to be covered with ice and glaciers are now actually turning into greenery because of life forms, flora coming up. So because of that, this interglacial intercycle is being exceeded. We are come into this place where
Thank heavens we are not there. We are there.
Yeah.
वहाँ पे, हाँ वहाँ पे.
So actually we are here, and if we keep continuing whatever things we are doing, we would eventually proceed into a death trap where it would become a hothouse Earth, and it won't be possible for us to even whatever measures we do humanly possible, it won't be able to retract those measures back. So it's like kind of a stable, unstable model. So this is unstable model, and for if we have to bring it back to stability, we have to own up our Earth system stewardship. Like we are as human stewards of our own Earth system, and we need to take measures like we did for ozone hole. We had that Montreal protocol, and where we actually reduced the ozone uh, hole so that.
So you are saying that. So you said the industrial revolution happened how many years ago?
1800.
So 200 years roughly. So 200 years of anthropogenic disturbances can cause, a complete, the disaster of such scale that the glacial interglacial cycle will change. And you also mentioned that if this should have not been there, we should have been in the glacial cycle now.
Yes.
So then it is good, right? We don't want to freeze.
So, but
you're headed there.
We are also headed to, if not glacier, we are headed to boiling water, which we don't want to freeze. And about the.
That's 1.5 degrees only.
Not 1 point, only 1.5.
That's the global number, right?
1.5 degree in 100 years, not in million years.
See, can I step in just for clarity?
1,000 years, how much temperature?
Yeah. Yes, sir.
Just for clarity, let me put this in perspective. See, the whole issue that is being told here is, these glacial interglacial cycles work on 100,000, 400,000, 20,000, 40,000 times scale, right? Now, what humans have done, and because Jyoti raised this point, with the Earth is sitting in that zone of instability there, the little Earth that they show, we have crossed that, because, in terms of the glacial interglacial cycles, the band in which carbon dioxide varied in the atmosphere was from 180 ppmb to 280 ppm. Never crossed 300 ppm. It has crossed 300 ppmb and now gotten to 420 ppm. All of that has taken place in 100 years, as opposed to this glacial interglacial cycling, which went on for 1 million years and it never crossed 300 years. So that is the critical part, that diagram.
Yeah, so that is the thing,
The
it's
rate
very.
that- the rate that-
Yes, it's very, it's a hypothetical statement to say that the glacial interglacial cycle will really change because of the anthropogenic.
So that can't change.
Yeah, absolutely. That's what I'm saying.
That is being, changed.
That can't change, yeah.
It's only because of that cannot change. That is being run by the Earth's orbital parameters.
Absolutely. That's the scale and everything is completely different than.
Yeah, but on that
Yeah.
you have superimposed this greenhouse gas system.
Right.
That overprint is causing it.
Yeah. Okay, good. But I thank you for bringing this topic in. I think it fits very well with the theme of the event as well. Very good.
And it's very inspiring to see somebody
Absolutely.
enter the EES major and be brave enough to come here and do that. That's subtle messaging to all our grad students.
PhDs mostly as well. Yeah.
That's what I
Let's give a huge round of applause for the Now, I request everyone to please enjoy the lunch. We'll gather back here at 2:30 for the next plenary round.
We have food manager.
वहाँ पे attendance माइक कहाँ पर थी कैमरे का वो ये स्ट्रीमिंग स्टॉप कर दो हाँ बाद में कर देंगे फिर से स्टार्ट एक मिनट